Hello, welcome to my stream tonight. Sorry I'm running a minute late, it looks like, but I can still spend another minute here waiting for people to join. Tonight hopefully is going to be a little bit of fun. It's going to be a little bit of drawing too, I imagine, which will be fun as well, hopefully, because I'm going to try my best to explain a bunch of the topics that we've been talking about on stream. It's kind of come up a couple of times now where people have, mentioned they're like, I feel like I'm walking into the middle of a conversation that's already started. And in a sense, they have. This has been kind of building up for months now. And I thought it'd be really nice to kind of take a step back. All right. Happy Friday. Let's give some greetings to people. You joined on time or I just joined late? Same thing, right? Hey, David. But yeah, I know that I am not always the best at explaining things. And that's okay. I don't have to be. But to help with that, we're going to actually have Dan Jutan, who is basically responsible for the whole docs team on Solid, to help me out here because he is great at extracting the useful parts for teaching and helping people actually understand what I'm saying. So hopefully together we can answer a number of those questions and kind of, make these topics a little bit more clear for people. I have to admit, I always start with This Week in JavaScript, and that's usually like straight into the deep end. So I'm going to try and be a little bit more conscious of that tonight, just specifically because I think we're going to kind of backpedal a bit and talk about some of these concepts at a more fundamental level. But yeah, it's definitely something to think about, especially considering that the topics this week in JavaScript were kind of technical. So anyways, without any further ado, yes, it is a mojito tonight. I'm going to invite Dan here on the stream.
Hey, is it working?
Yeah, you are here.
Cool. Yeah, it's funny because the thing about This Week in JavaScript is that half of it is like this super complex technical side, which is like, we're innovating on this front, let me tell you about it. And the other half is like gossip and drama, which you need like no technical knowledge to understand.
Yeah. So yeah, hopefully it's enjoyable for people. And yes, no, tonight is not a magic stream. I'm sorry. Maybe one day. Hey, Ryan. All right. Well, I guess I got enough here so that we can actually get started. So what are we doing here? 3:20? Yeah. Actually, I'm running late. So yeah, let's just.
David's like, we love the drama. David's like, I make the drama.
Yes. Oh right. That yeah. There was some fun. I wanted to find that Astro tweet. The one about the Astro Solid. We'll look for it in a minute.
Yeah, the JSX.
There's some drama in there. Anyways, I'm gonna share my screen here, and we're gonna get into This Week in JavaScript. Of course, my luck is this isn't gonna work like that one other time that it didn't work. No, we're good. All right. So This Week in JavaScript for me started scrambling Tuesday morning because Netlify announced that they were releasing their new Edge functions. And to be fair, I knew it was coming. Some of the frameworks had gotten some early access, and they'd actually reached out to me towards the end of last week. And I was like so busy trying to get ready for the stream and whatnot that I didn't actually get to looking at it till Monday night. And I was working on it and I found a few issues and I was like, okay, I can't release this. And then Tuesday morning it was out and I was like, oh crap, okay, I'm going to figure this out. Yeah, the announcement went out and I started scrambling to get my Hacker News demo up and managed to do it. But the kind of, and if you didn't see it, we posted it up. It was the typical solid start setup with TypeScript, JSX, on top of Vite. There's the whole streaming SSR at the edge. That was kind of cool. I didn't realize they had streaming until I was like in there playing with it. I was like, oh my, wait a second. There's streaming interfaces. So kind of discovered it without any docs. Figured it out. The whole thing with the span stuff, code splitting. And this is actually, the Netlify stuff builds small. It's some of the smallest payloads we actually have. I wrote 12.6, but yeah, it's 12.5 kilobytes of JavaScript on that initial page load. But the one thing that I found was that the streaming wasn't compressed. Essentially, they weren't gzipping the streamed responses, which was a little bit awkward for the kind of performance testing I do. But this actually pushed the team at Deno to actually get streaming in, and they actually added it and released it today. And I didn't have to do anything. This example now, to my knowledge, is fully streaming. I mean, we can take a quick look here. And
by the way, one thing, like this, there's no node here. This is all Deno. So like is that true? Like the solid function render to stream or whatever solid SSR function you're calling, that's all running on Deno.
Yes. Yeah. Exactly. Yeah. It was very similar actually to the workers API. So it was a very quick lift and set here. But yes, it's completely Deno. And yeah, I mean, let's quickly do here. I mean, maybe I'll explain what I'm doing a bit more later. But I want to double check that everything's good, but yeah, let's quick do a profile. And what you'll see here is HTML response is this big blue thing up here. Resources are loading before it is done. So yes, streaming is working. If we go in the network tab and look at all, yes, 6.2 kilobytes. So our page is small. It was like 30 when I did this release, and we'll see content encoding gzip. So they're doing gzip here on the response. What I was seeing before was asking for gzipped or deflate with the accept encoding, but not getting that back. So now we have a fully functional example, and I have to admit, it looks pretty nice. I'm pretty stoked on this actually. I actually made a straight Deno deploy version 2 and added that adapter. So now
I was about to ask you, like, does this work on Deno deploy?
Yes, we added that adapter this week as well. But let's just do. I just want to see. We got Cloudflare here too, so we've got these both kind of sitting right next to each other, and yeah, I mean, one thing that I found, and I don't know if it's the API location or whatnot, but yeah, these, I mean,
was this solid start?
Yeah, this is all solid start. Yeah, I don't know why that. What's going on here? This is, what my problem is. I should not be doing this in a normal browser window. You should always use incognito because
like your extensions or
like Grammarly is mean.
I use Loom, and Loom sticks DOM elements everywhere.
So yeah, let's not do that. Usually I always have this, but let's quickly just do a look at the profile timeline here. Our Cloudflare, end of our Netlify here. Ooh, that looked fast. I think we're all talking. Holy crap, that was fast. What happened there? I've never seen that fast. 67 millisecond first paint. And and this is the lovely part about streaming, right? And I'll maybe explain more in the end. And then it's all done by 131 milliseconds. I don't know. I think that might have been a bit of a blip. Where our Cloudflare was 228 and Force 34. Let's give Cloudflare another shot here. I think we can do better. Or not. Yeah, here we go. This is more typical. 130 first paint, and then we're kind of all done around 340. So yeah, I don't know what's up with that. Maybe it's this Hacker News API. For this demo, this Netlify Edge version is the fastest that we've seen in terms of this. To be fair, this is like, I just mean locally for me. So I think it all depends on where the edge locations are. And yeah.
This is one of the things, by the way, about Edge that makes it hard to wrap your head around, is that unlike traditional server-side stuff where you have your LAMP server or your Node server, you can't do Edge locally. The entire point of Edge is it's somewhere else special close to the user, and so you can't like see it or conceptualize it unless it's literally running on, Netlify or whatever.
Yeah, and I mean, we could probably do our mean example, and don't get me wrong, this is not going to be as nice as those Astro scores we saw, a week ago, or even Marco I showed last week with the split components. We got into the low 80s without doing any kind of deferred stuff, which again we'll talk about more later. But I don't know. I mean, I wouldn't be doing my due diligence here if I wasn't showing people on stream Netlify versus Cloudflare.
Yeah.
So this is just a little fun for people.
One thing about Dino deploy is that
sorry, that was the remix example. That was my bad.
Oh, it's okay. We can show off how bad remix is. Wait, what? Oh no, that's not what we're doing. Sorry.
Don't go there. You know what? The solid start Svelte kit and remix are all basically identical in this example.
Oh, okay. I was like 36. I was like, wow.
That was just an unlucky run, right? Okay, there we go.
Okay.
54 for solid. And actually, you know what? I think what we're going to see here is when the load is heavy, we're hitting almost a local maximum on SPAs. It's basically going to be the same in every framework, and it's going to be the same in every edge deploy or whatever. Like when we, at least in this tool, when we get here, like
you mentioned that there was like a good run or a bad run. Do you have to run this like 100 times to get a good sense of what's going on?
Not often, usually within 3. The thing is, there's just like, there is some inconsistency here. I mean, okay, there's a 48. I mean, we can run it again. We saw last time when I did this that all the frameworks got about 47, including this run got 47. My gut is there's a range, plus or minus about, there's a 10-point range.
Gotcha.
So if you run it enough, you'll see the different range. So we got 50. Let's just look at the numbers here. This is suggesting the Cloudflare.
How do they calibrate this thing? Like, how do they choose what 100 is?
Yeah, I mean, that's the thing. These scores sometimes weigh. I've shown the client CSR killing client-side frameworks, like the version with no server-side rendering. So because it got such a high contentful paint. And again, we'll probably explain this differently later. But yeah, it's just funny. Earlier, I ran this one and I got a 55. And, this one we just got a 54. I run it again, we might get a 50, or that remix got a 36. We've seen 50 or 47 on the stream with remix. So yeah, we got a 47 this time with Cloudflare. So we're still in this 50 range on this. Part of this is there's so many pieces where we can actually hit latency. Like we're depending on not just the worker response time, we're depending on the API. This is a third-party API. We don't control that, right?
Right.
Yeah. So yeah, I mean, when there's a good run, we're ballpark in the same range here. Like the Netlify replied faster, but spent more time getting to interactive. Like this is the same code, and this is a good point. Like the hydration costs for these should not be different. So, I mean, how much do you trust this? Yeah. A second different on hydration cost is kind of significant. So, yeah, keep in mind there is this kind of variation. Okay.
Yeah, it's interesting to think about how do you take most advantage of being on the edge? Your third-party API is a good example. What about an image hosted somewhere else? How do you make sure that it's hosted here to take advantage of Edge? I don't know. I still haven't wrapped my head around Edge properly. I feel like I'm a really good Edge beginner.
Yeah, that's good. Maybe we'll get to it. I suspect that might be a little bit out of scope. Anyways,
probably, yeah.
I'm pretty stoked about this because there's a lot of performance here. And Netlify now joins the ranks of Cloudflare and Vercel, who use Cloudflare. So we have two major players right now on the edge, and that's Dino and Cloudflare. And now all the main providers that we go to have edge, and they have streaming, which means that like they're prime for solid start. Or Svelte, if you take it. Guillermo wanted to show off today that static rendering and Svelte rendering was almost imperceivably different. I don't know what kind of page he was rendering, but I'm not surprised. Either is Michael Rawlings from Marco. It turns out that HTML string and cat on the server, which what Svelte, Marco, and Solid do, is much faster than generating a VDOM or loading up JS DOM. And Rich Harris weighed in to agree. He's like, yeah, this is one of those kind of under-discussed problems with stuff like this shadow DOM. It's only really appropriate for static content since you need a server-side DOM implementation, just as web dev community was waking up to the folly of Jamstack, right? Not to mention, you can't stream into the shadow DOM. So
my brain is like breaking thinking about what that means.
Yeah, I mean, sure, that's fine. As I said,
just to be clear, like the post here is saying that running Svelte, running server-side Svelte on every request is very cheap. So like comparing that to just running your server-side Svelte once, saving it and serving it is almost no difference.
Yeah, and we've seen some of these benchmarks before, right? Let me see if I can find it. Isomorphic UI benchmark. Marco did these ones, but let's see. Can I see the forks on it? Not create fork. I want to see the forks.
Oh yeah, I was looking through this week. We were talking about it. I'm like, why doesn't Solid get a thing in the image?
Well, it's because I haven't merged it yet. 32 forks. Let me see if I can see it. Yeah. So where's my version? Because I actually went and updated. But look at some of the names on here. Evan Yu made a version. He did it. True ADM, Inferno, Svelte.
Love it.
So this isn't the JS framework benchmark, but this is as close as you got for a benchmark that for server-side rendering today. And there we go, Ryan Solid's version. And don't go to my profile.
Oh, you don't want to talk about the new GitHub 3D landscape model of your commit graph. Have you seen that?
No, I don't think I have yet. But what I do want to do, and I'll get it, is go to my updated branch where I actually updated the frameworks and ran the results, and have not updated these graphs. But you can kind of see the advantage of using string over most VDOM. Don't get me wrong. Inferno is fast. Yes, Dylan. This benchmark can be better, but it is the best we have on the server side stuff, unfortunately, for the raw rendering. You can see it right here, though. Look at this. Marco 8000, Preact 900, React 800. It's like 10 times faster rendering on Marco. Vue does a valiant effort at about 2600. So that, and Inferno about 3000. And there's actually two benchmarks. The first one here, the search results, is actually an eBay page. So it's a huge amount of static content. So this really taxes more VDOM type things because they build a bunch of nodes that you don't need. Solid 22,000, and Svelte actually isn't the best on this one. I've been kind of helping. I kind of pointed Svelte in a direction where they have a PR that will increase their server rendering by about 4 times. So they should get very close to the Marco numbers when they merge that PR. But yeah, you can. I mean, this kind of Svelte actually undermines what I was trying to show here. About the VDOM being slower than string concat, but you can look at Solid and Marco to see what performant SSR looks like.
Are you saying that like the posts, with Svelte being a lot faster than,
Yeah, being a lot faster than React is kind of like shooting fish in a barrel.
Yeah, because I mean, in this case, Vue has a better argument to the same thing, and they use a VDOM.
Yeah, exactly, right. And to be fair, yeah, Vue actually has made some nice improvements on SSR. Like even here, Svelte is 6,000, Vue is 8,000, and Inferno is 24,000. The color picker is a much simpler test. It's just like a color picker thing, and it's a more dynamic test. But you can see that right here, Marco 20,000. Inferno actually. This is inaccurate because I actually looked. Inferno, it has a bug where it's not escaping a certain thing it should be escaping. Its real number, it should be more like 18,000 here. It's actually leveraging the fact it's not escaping something. There's an issue here. But generally speaking, Inferno is very fast for a VDOM and it's super optimized. So sometimes it's not just a VDOM thing, but yeah, Preact and React are again, what's this, 4 times slower than Marco and more like 12 times slower than Solid. So yeah, I mean, when you kind of get away from we're talking order magnitude server-side rendering performance difference, like when you're going to these string renderers, well, I guess except Svelte, but compared to the VDOM, generally speaking, Svelte's an outlier on the string side, and Inferno is an outlier on the VDOM side. I mean, the guys who wrote Inferno know what they're doing. I'm a huge fan. Everyone knows that. If someone's going to show you that the VDOM is capable of amazing things, it's going to be that. And I know Dom gets a lot of credit because of the initial design, but even the people who currently maintain it, he attracted some of the greatest minds on the VDOM side in terms of raw performance. Don't get me wrong, the React team is actually incredible. People undercredit that hugely. This is a raw rendering benchmark. They're concerned more about full application considerations, but when it comes to raw speed, the kind of stuff that Guillermo is talking about here. Yeah, I mean,
this is the CEO of Vercel, right?
Yes, this is the CEO of Vercel. This is kind of like strings are where you want to be, as I said. I mean, I'd love to do more benchmarking here. As I mentioned, Svelte's good, but I think both of my frameworks are much better. So we can do more. Looking at that.
You simultaneously make the argument that we can do better benchmarking and that we should probably move on from benchmarking.
Yeah, I mean, it has some value for the maintainers. While I don't think people should base their framework decisions on this, completely, unless there's a business case to be made, don't worry about it. And observe your own code. Look at your own bottlenecks. Your bottleneck's probably somewhere else. But for library maintainers, the best we can do is give you the best floor or whatever. Give you the best stuff to work with. And for that reason, benchmarks are great for us.
Yeah, I love it.
I sat there when my first version of the Solid SSR was using JS DOM. It's hard, when you have a reactive system and all this stuff, and I was using reactivity on the server. When you have all this stuff, you're just okay, well, that's where I can start. And actually, that's where Quick is kind of today. You kind of just have the system, and you're okay, well, let's get server rendering. And then you do it, and you're yes, I got there, right? I worked a bunch. I just kept on peeling back and benchmarking and testing until I get to a point where Solid arguably has the fastest server rendering today of a JavaScript framework. And it was through those benchmarks. And I've seen this again happen even in the client, the JS framework benchmark. Major props up to why is his name escaping me right now? He's big in the Solid Discord. He's been working on a reactive framework very similar to Solid, and Vobi is called, and he's managed to actually get out in front of us. Part of this is a bad run, but it's very comparable. And compared to Compostate, which is also based on, I think, DOM expressions and some Solid, we've seen in the Solid community, I've seen 3 or 4 people over the time come in and build their own reactive render from scratch and then learn all the lessons through using the JS framework benchmark. Yeah, Fabiano. Yes, thank you. Yeah.
Oh, that's him. That's awesome.
Or Fabio, maybe. Yeah, sorry. Yeah, the Vobi, or I think it's called, is what is his doing. And I mean, this even goes back earlier. Sinuous. It was a fork of my Hyperscript version of Solid, but he again tuned it to make it smaller than what I did, incredibly small. Let me see where he's at.
Yeah, it sounds like
he's 2 kilobytes smaller than solid. So like these guys, yeah, as I said, it's been 3 or 4 times. Use this benchmark as a way to confirm, including myself. We all use this to find the most optimal ways to render the DOM.
in a sense, you're using it to compare to yourself. Like you're using it to
Yes.
weigh the engineering cost, the costs of these engineering decisions.
Yeah, that's how we learn. All right. So yeah, don't just like go, there's more to the life than benchmarks, but I mean, it's a hard challenge. And I like even block DOM. This is a VDOM right here. Look at this. I mean, there's these numbers are all really close. We're getting more and more entries up at the front. So like, yeah, and every run's a little different. So this like the difference between these is kind of more accented than you'd think. Like maybe I should get rid of the stuff that's not real. But yeah, block DOM.
Where's Elm, my favorite JavaScript framework?
Not that far back, right here.
Cool.
Elm's 131. So it should be very close to Svelte. Yes, Svelte is 125, and Vue should be Vue. Props on them. Eh?
Look at that.
Vue got in front of Svelte recently. So yeah. Yeah, so I mean, it's just one of those things.
If you guys don't know, Elmo stack is my meme stack where you use Elm on the front end and OCaml on the back end, so you get like this amazing functional programming stack.
But yeah, my point is, like, there's different technologies and different approaches, and this kind of stuff pushes innovation. Like, this is the fastest VDOM implementation we have ever seen. It actually got faster than a reactive thing. I knew it was theoretically possible. I wasn't sure if it'd like show up in front of solid or not, but I knew that conceptually there was more we could do with the VDOM. So, this is really, really quite cool. I don't talk about Mikado much because it kind of is not doing the same thing as the others. I think it's kind of, this one probably deserves like a 772. It's not the same, but generally speaking, we have a lot of different approaches here, and I think it's really cool. Anyway, sorry, tangent, but just understanding that benchmarks still have a role and that performance is still a real thing. Okay, let's continue with this week in JavaScript a little bit then.
Yeah, I'll butt in less.
it's fine. People like this stuff. Okay, so yeah, Taylor Hunt released another article, and he was basically explaining why he didn't go with a single page app router. But this is actually a good article talking about the benefits and trade-offs of single page app routing versus multi-page app routing, which again is a topic I want to cover today if possible. So I quite enjoyed this because it was a lot like Rich Harris's transitional app talk from last fall, and I think it just puts into perspective that we're always dealing with a lot of trade-offs. And honestly, that talk about routing got me thinking again, because again, I'm going to reference a bunch of docs. I think people should read these things if they get a chance. But Igor Miner, if you guys are not familiar, he is one of the core. He was one of the core maintainers. I almost call him like a lieutenant, so to speak, of the Angular team. Like Angular is one of the biggest framework dev teams. So, saying you're on the Angular core team might mean you're pulling a couple dozen people or something. Igor was like one of the, main people there. You can go online, find his conference talks to that. He recently moved to Cloudflare to redefine how the web works on the edge. Again, edge, big deal if you're playing keyword bingo. And he described the different JavaScript frameworks as different generations. And he said, like, we're currently on generation 2, but generation 3 is coming in. And one of the things that was interesting for me is I saw some of the generation stuff. Like generation 0, like the classic websites, which, that was a thing. And I saw the single page apps, and that was another thing. But then I thought we're going on to the third thing now. He added something in the middle. He said, there's a difference between the single page apps that were around in 2009, 2010, and then the ones that were kind of around in 2015. even though React kind of crossed those boundaries, from his perspective, there was actually a shift when like the Next.js's of the world came out. And it was funny because I wouldn't have made that distinction before, but once he said it, I'm like, he's talking about routing. He wasn't talking about routing. Yeah, no, Igor is like.
And the article, by the way, you know, even if you're not so interested in like the generations of front end, just to see his perspective as someone who built it from the beginning to now was an amazing article.
Yeah, no, for sure. And it's very human element to it. He actually talks a bit about his struggle and his journey. So it's a great article overall. But for me, when he made that split, I immediately lined it up to routing, because there was a difference between Gen 1 and Gen 2. You couldn't really do the same kind of server-side apps as you do today when all you had was hash state in the browser. We needed real URLs. We needed push state. And even though he didn't really, like, he, in my mind, almost invented a new generation, it actually aligns exactly with the paradigm shift in routing. And what I've been saying is that there is a paradigm shift in routing happening right now. So this was really actually quite exciting for me, because like once it clicked on me, I'm like this is just even more emphasis on that. Of course, what ended up happening is it pulled out, you know, the HTMX crew, and this is basically like the future of like Gen 0. I actually like this image a lot. It's kind of a funny thing, and I got to give them some props here on how they're approaching this.
I mean, the middle is supposed to be Next.js, right? Like,
yeah, exactly. This is like the modern kind of thing. You know, you got your APIs over here, and then you have your server MVC model, and you have your client MVC model, and there's actually, you know what I mean, like the component model. And then what they were saying is just go back to the beginning and look what they did. They actually removed the JavaScript. So it's interesting. There is some proponents of this kind of side of things. I think it's good for some things. I think there's a reason why we ended up here. I think we can do better, but not necessarily.
And by the way, the differentiation made in Igor's article, like, gets back to something that, something I learned from you, which is that from a beginner's perspective, Next.js is not a SPA. Next.js is marketed to us as like, look, we're pre-rendering your thing, and so it's different. But like in your mind, it's all part of this SPA generation. But you can differentiate in the sense that, well, it is letting you do some like server side, client side routing, special magic.
Now we have a differentiator, 1 and 2. It's funny, it never crossed my mind like that. Like even Swix's article, the 3 ages of JavaScript, he put 1 and 2 together himself. I think the 1 and 2 split was much more obvious for the Angular team, because they were there at the beginning of generation 1 with Angular.js, and they came in right as Gen 2 was like starting to take off with Angular 2. Like they actually made that switch over that gap. I don't think they were necessarily the definers for the second gen, but essentially they were there right at the beginning of Gen 1. And for that reason, it was very clear to them what the difference was. Where
the age lasted longer for them, so they can cut it in half. Like,
well, yeah, and there was a difference. There was a critical difference. Right. Whereas if you came up with React, you might have just saw React as like leading into Gen 2. And in a sense, it was all just the same gen. I've seen this before. Some people, this happens all the time, actually. People kind of go to me and they're like, React was revolutionary. Like, you had jQuery and then you had React.
Right.
They like literally skip Gen 1. Like, I'm like, no, React was amazing. It was a game changer. But it was actually, like, from my perspective, and I've talked about this a bit before, it was incremental. Like there was this generation 1, but for a whole group of developers coming in, they just like skipped that generation 1 was a thing. Yeah, it's funny, but Yeah, I mean, I've talked about MVM, MVVM, and MVC. This is that, at least that knowledge is stuff that I don't feel like we need to talk about today because it's not part of the future of web dev. It's the past that might not actually matter as much. But yeah, so is there anything else I can talk about before I go there? Yeah. Before I'm going to go there, I'm going to talk about people voting for Solid Hack. No, it is true though. If you get a chance, everyone should try and vote for a Solid Hackathon. It's, I think there's been over 50 submissions, and show support to people, the participants. Check out the project; it's a lot of fun. I saw some people tweeting and talking about it this week, which is great. So definitely check it out. And also, while I'm at it, I was on JS Jabber, which was a lot of fun.
I was listening to this today. I think it went really well.
I'm glad. I was worried. Dan really is the driving force. I'm not you.
He was he was asking those really good conceptual questions.
Yeah, and he basically what was I going to say? He had to leave early because it was right after the time zone change, and the time zone the clock's changing, and they didn't change for him. So I was really worried that after he left, it would kind of drop off. But the final product kind of came.
I only listened to the first 20 minutes, so I need to go see what happens after he leaves.
No, I mean it was good, but yeah, I think it's one of those things. Okay, yeah, good. We got more stuff. I'm choosing to skip over some stuff because it's a little technical, but we'll get back to it again. I do actually, yeah. Sorry, this is a tweet where we were talking about Netlify getting the stuff, and yeah, they got the Dino within a week turnaround got everything updated, which is amazing. Okay, yeah. So
the big Mishko article was this week. Right?
Yeah, I'm skipping it. I'm leaving that.
I didn't even have time to get through it yet, but it looked really monumental. I have to check it out.
Yeah, which is I'm leaving that to last. So I'm going to talk. I actually released a Marco article this week, which I am super stoked about for people to check out. This is I've been waiting to release this article for it feels like a while. It's so funny because we wrote these first articles in the series in November 2020, and now it's March 2022. We went through a redesign through that point, but we've been benchmarking at every point, figuring out the kind of the best approaches, validating that our thinking is right. I've seen Marco go from basically parallel to solid to back to svelte multiple times over the last 2 years. But finally, we know that we've taken care of the edge cases and we're in a good place. So, I finally talk about what it means to have a compiled fine-grained reactive system, what the performance looks like, which I think there's some improvements still to be made, but we're talking Inferno performance. Marco, this is the biggest jump I've ever seen in a JavaScript framework here. I was very impressed with you, jumping 30%. Marco is jumping 100% on client-side performance. And, it's funny because we do so much work and the end result is really something quite simple. You just take stuff and split it into functions and have functions call other functions, and bye reactivity. It's funny. You write stuff reactively so we know how to break things apart into functions, but then the execution is literally just simple function calls. If you change the value of A, then you do all the updates you need to do for A, and then all the updates you need to do where A intersects with B. And that's it.
When we're talking about Marco and reactivity, is this really Marco's foray into that SPA area?
It's interesting because Marco, you could always build a SPA with any MPA framework. Astro likes to talk about, you can just put a SPA on the page. So you could use Marco that way, but it's kind of why would you ever do that?
Yeah, why?
Yeah. When Marco does this other stuff, you don't need a client-side router. And again, when we talk about architecture later on, this will kind of make more context. So not really, but it's nice when your performance is this good. No one's going to complain about you being a SPA. React has edged up over the years. React and Marco and Angular used to be all the same around 2.10. And you can actually see some older versions of React in the benchmark, I think, and they're still out there. But React has gotten a little faster. Each version, 17, 18, they kind of gone a little bit faster. To be fair, everybody else has gone way faster during that time period. Vue, back when React was 200, Vue was about 1.7. Vue is now like 125, which is like, amazing. But when your performance is up here, no one's going to complain about you being
I guess what I'm trying to say is, like, in my mind, if we're not talking about features relating to routing and building, then we're in interactivity territory where it doesn't matter if you're a SPA or an MPA. Like, does that make sense?
Yeah. But I mean, the routing is really important, like I was getting at earlier. So I can almost never talk about these things without talking about routing. But yes.
Yeah. Well, I'm saying this example has nothing to do with routing. So it's interesting to me for that reason.
Well, and that's the thing, right? This article focuses on composability and it focuses on size. The reason we kind of did this is someone commented to me, they're like, man, Solid isn't the smallest at any size point anymore. And they're right. Before, this was Solid's like strength, around 5 to 10 to do MVCs on the page. So roughly multiply that to 2 to 3 for components. Like, so around the 20 component range, Solid was the smallest framework. It was still respectable, kind of going up. And to be Preact and Solid Preact is actually pretty small here, and they kind of keep neck and neck. But Marco is now taking over the area and gone even a little further on where Solid was the smallest, and cut into Svelte considerably. Like, Marco optimal range here between 5 to 20 is exactly what you want for an islands or partial hydrated framework, because if you're up to like 80 to do MVCs on a partial hydrated page, I don't know what you're doing. Like, that whole point is you don't ship the JavaScript. And that's why this is a funny article for me, because Marco 6 is really good in an area that it doesn't really care about. like it already doesn't ship 80% of the page. It's like Astro. You don't ship 80% of the page. It's the last 20%. And it's like, at that point, when you have options like Marco and Solid and Svelte here, especially on the smaller end, like, and Preact too, it's kind of just like, why are you doing anything else?
I think comparing Marco to Astro is interesting for this kind of reason, where Marco is opinionated across the stack, so to speak. And so you get interesting situations like this where it's like, oh yeah, because Marco is so great here, it doesn't need to be as great here, but it might as well be, like.
And the thing is, last week we threw the gauntlet, or not, 2 weeks ago we threw the gauntlet down. The Solid Marco demo, and Solid's the best in this range. The Solid Marco, the Astro Solid demo was the smallest to do MVC, or sorry, Hacker News version we'd ever seen. It was 5 kilobytes. It was 4.9 kilobytes essentially. I think Marco can do better there, but I think it's really cool to see partial hydration with a super small, super efficient, performant framework. Like, it's cool that before Astro, like, you look at Marco and just be like, I mean, it's funny, most people wouldn't look at Marco, but you look at Marco and just be like, I'm never going to beat this. Like I don't care how fast my JS framework benchmark performance is or any of this. When that page loads, nothing's even close. I mean, I make comments like this and people think, oh, you're just being super polite. No, it's true. It's like the biggest hidden secret in JavaScript frameworks, that for like the last like 5, 7, 8 years, like for page loading in JavaScript frameworks, Marco has just absolutely killed it. Like, it's just not even close. It's almost embarrassing. People were like, oh, what do you think of SSR and Next and stuff? And I was like, oh, I don't know. It's like a 2 out of 10. Like, and I'm not saying that Solid is any better. I'm just saying, like, Marco was like that much better in that range. And then Astro is kind of interesting when you have frameworks like Solid or Preact or Svelte. You actually can do a really good impression of like old Marco. Of course, new Marco in that area is going to be a whole game changer, and there's going to be a follow-up article when we talk about this. But this was a fun one for me, because I've been waiting to show you what we've been working on, show you how, this is the area that I've been excited about and I've cared about. When I joined the Marco team, it was like, how do we change how the browser part works? That was kind of like the thinking why when I joined on the team. And to see this is incredibly feeling of success to me. Even though a lot of credit goes to obviously Michael and Dylan, it's just like we took a completely different framework, philosophy, approach. HTML first, like the almost something on the svelte side of things, and show that you can just jump the performance all the way up the tree. Like you can get here multiple ways. That always excites me. I was showing you about the VDOM, how you get that performance out of block DOM. Like this performance is there for anyone if they choose. It's obviously stuff like the islands, the hydration are a trickier question, but I really believe that it is possible with the right architecture, maybe a fine-grained one, that Vue or Svelte or others could potentially get into the type of performance that Marco and Solid have been enjoying. So yeah.
Congrats to you guys. I know Dylan's here, and also I just want to say we're moving forward with like the tags API, right? Like the Marco DSL system that you've demoed in the past.
Yeah, exactly. Yeah, for sure. Yeah, and
I always loved that. Coming from things like Vue, like I thought, turning a variable into sort of this like declarative HTML tag and just, yeah, I love this. I don't think this gets enough credit. I don't think people talk about it enough. I think it's super fun from a design perspective to look at this and be like, okay, this is kind of cool. HTML is everything. This is also JSX.
What's also cool about this is, and the things that get kind of over thing, and I won't dwell on here too long, is when you have stuff laid like this, when you can just like have the effects next to the, the state next to the DOM, like you just cut and paste sections of code.
Yeah.
And because it's fine grained, like Solid, it just runs once. And as you know, the state can be located anywhere. There's no hook rules or anything. You can nest it in a for loop. You can do all that with Solid as well. The JSX doesn't always lend to it, but you can always just like make a for loop and then go, okay, I'm just create signal inside. Like that will work.
It takes the Vue/Svelte DSL thing further because in Vue and Svelte, your DSL is connecting your markup to your state somewhere else. Here, because your state is part of the markup, it feels so natural. It's cohesive. It's very exciting for me.
It's crazy because this unlocks something incredible from an editing maintenance stuff. It might not even be clear here, but Marco syntax is also the most terse. Svelte prides itself a lot on being like write the least code. Marco now is write the least code. And there's even a terser syntax if you're crazy called concise mode that works like pug, like white space matters. But essentially, this is actually the easiest approach I've ever seen to refactoring and code writing pretty much ever.
Yeah, Dylan says we made reactive script. Some people call it HTML, and like, yeah, sorry for calling it HTML. Like, I see what you're doing. At its core, the idea of a reactive script is like everything is declarative by default, and that's what this is. So, and that's also what HTML is. HTML is just like,
people won't appreciate this right away. I hope they do catch on. But essentially, when hooks came out and you saw the way the colors kind of moved together and you could co-locate and you had to write less code, it's the same here. Solid has those aspects, but the JSX is like 80%, but not 100% of the way. Like maybe a JSX2 would do it. Marco has their own syntax, so they're able to just, we were able to just build it to this purpose, which is crazy because it kind of, as I said, it unlocks this capability that you just never seen anywhere else. Like basically, like the old I forget. I had an example with like effects and stuff that I was using in all the frameworks. And when you had to edit something, you had to edit in. Even with hooks, you still had to edit in 4 unique places in the code. They might have been next to each other. They might have been part of the same hook, like changing a dependency and all that kind of stuff. But with Marco, it was literally one location. Like and because it's one location, you can just cut and paste it. Like,
I heard I think Dylan on a podcast, and they were really grilling him on like, so did you guys like spend thousands of hours making VS Code extension for this, and he was like, yeah, it's a pain point. So like there are like rough downsides to this approach, but if you have those resources and if you implement those, I mean, it feels unique, but it feels designed for a purpose. Like,
Yeah.
And I really appreciate that kind of design.
For me personally, and I have actually, this is kind of leading, and I have a blog post or another article coming out next week actually talking about Marco and Solid. This is an exemplification of a direction that you can think of. Like Svelte had kind of showed people like, oh, compilers are the future, and everyone was kind of on that path. A lot of people thinking that's the future. Marco can kind of show, whenever I always say, when I see Marco, I see Svelte's future potentially. Like like Svelte actually added const, const tags or to Svelte very, very recently. And
I didn't even know that.
That's me a little bit, right? Because obviously we've been designing this, and we have a Marco tags API last summer. Like this is our dollar sign, actually our scriptlets in Marco was actually kind of that. We've had this for years and years and years, and Svelte's kind of like discovering this, and it's kind of funny, like that's on that side. And sometimes when I view on the reactive system, I feel like they're discovering a lot of the stuff that we knew about from the solid side, and viewed philosophically maybe more on the Svelte, kind of side of things. But what I'm getting at is I think there's some competing philosophies here. And I mentioned what excites me is the fact that all paths lead to Rome, maybe slightly different. And I don't know, I for me right now, there is still maybe two high-level philosophical things. And I think that both approaches, I want to see where they get to. And for me, one approach to that, the kind of just JavaScript, localized, almost runtime compiler is part of the equation, but just like you just write JavaScript code, like solid React is very much on that side. And Marco is showing what the compiler owns the world. I'm a language side. It's like framework versus language. And I like the fact that we can explore both of those. So, yeah, I think this is super cool. Sorry. Which we're going to move on to the next topic here. But yes, we're going to talk about Marco a lot in the coming weeks, especially as we make progress in the alpha. We're going to talk about hydration, which is the last topic here I want to talk about, because Mishko have released this article, and actually helped them a bit with it on the editing side, kind of make it hit. But
I noticed that because I've read things he's written before. Obviously, I'm a very writing oriented person, and like I could tell this was a team effort, and I appreciated it a lot.
Yeah, I think this was an interesting one, because we had to kind of push it a little bit, because Mishko had the idea. He knew how to explain the problem really well. He had the whole explanation of it. But the tricky part of this kind of article is you don't mind if people get kind of mired in the details when you're talking about the overhead of hydration, but you don't want people to get too mired in the details when you're talking about the solution, because otherwise, if the solution's as complicated as the problem you're solving, people are just going to turn off.
Yeah, so, it needs to feel like you found the magic bullet, even if behind the scenes the magic bullet is pretty complicated.
Exactly. So that was my biggest contribution. I read the original article, and I'm like, you can listen to me or you're not, Mitsuko, but I want you to completely change the order of the sections and pull everything about the solution out to towards the end, and focus on the overhead part, and then kind of just lay out the solution, once that's happened, so we aren't kind of, and at the end, that, and with that kind of input, we ended up with this article, which I think the happiest thing about this article, and I don't want to talk too much about hydration versus resumability yet, is that people who classically are Gen 0, like on the classic MPA side, got it right away. We've had a hard time explaining this in a way that's compelling. The whole
that surprises me, because I would think they also don't like hydration as this almost render twice thing.
But they read the article for what it was supposed to be. The point of this article is you're not really hydrating when you're resumable. And Generation 0 frameworks didn't hydrate. Generation 1 frameworks didn't
Oh,
hydrate.
gotcha. You were afraid that they wouldn't understand that resumability is more like them, right?
Yes,
Okay.
and that's what they saw here. I didn't even, it wasn't that I was afraid. I just wasn't sure that like this was a new thing for me. A bunch of them came up, those people came out of the woodwork and they're like, yeah, we've been doing this for like 15 years. And it's like, yes, you have, because they start talking about progressive enhancement and all this stuff. And they're like, this just sounds like progressive enhancement. But the key difference here that you got to stop and think about is you're authoring your whole app the way you author like React. And then, kind of same idea with Marco. You just write an app, JavaScript app, full app, like not even worrying about islands and stuff. Like you're literally just writing an app. And then it hydrates like jQuery.
That was the incredible thing about Quick from what I've understood from it so far is like they've managed to have that almost paradigm shifting level optimization just be an implementation detail. So you just like write your app the way you would write it, and like they take care of the rest, and that is
right.
Yeah, right. I mean that's groundbreaking.
Yeah, I mean, if we're gonna call that groundbreaking, I'm gonna call Marco groundbreaking too, because
I think Marco broke the ground before anyone else was breaking the ground.
What I mean is like Marco's partial hydration was automatic in the same way. You'd write the code as normal, and then Marco would discover the islands for you.
Yeah. Like with Astro, we think about it, we choose it, it's deliberate.
Yeah.
With this, it's
right, exactly. But the big thing is, this is more granular. So, and I think that's the key. Once you got to the granular, once he basically said, look, we're not doing anything but attaching event handlers, I think it finally clicked, and they're just like, yeah, that's what we do. Except this is crazy because it's actually this full declarative app. Like if the other option is basically having two apps, render on the server and then like have a JavaScript layer on top. Unifying that, yet getting the benefits. This article really shook up the conversation, and there's a lot of clarification here. Enough that this kind of almost encouraged the stream a bit. It was the comments, about I don't understand what you're talking about, but it was also just like I feel like I'm gonna have to write an article like WTF resumability because
I also like. When I got to this article, I was like, I need a weekend for this. Like, I'm not reading this like on Wednesday at 5 p.m. or whatever.
Right, and part of it is, I've written about resumability and this hydration thing before, and more from a human angle, talking about how both Marco and Quick independently stumbled on this kind of solution, and almost exact same time, really, and essentially started working on it and recognized that it was like a better hydration, but didn't recognize till very, very recently that maybe it's not even hydration. But we'll talk about that more. It's just essentially this has been the conversation basically all week for me. Like, actually, you'd appreciate this one, Dan. I just retweeted it before the stream. This article here is talking on hydration for non-technical.
Oh, I have to read that. I didn't see that. That's amazing.
It doesn't actually talk about hydration at all. It just talks about the confusion around the language. And I think I'm going to pull this up right now.
Yeah, I wish I read this before.
Just because this interaction actually happened on Twitter. I was we talked about web components, and I think you can tell this guy has like, he's a humanities student or something. Like you could tell just at the background, like he's taking this very much from a language sociology kind of mentality.
The philosophy of explaining stuff on the web, yeah.
And look at this exchange. Foo, you don't need JavaScript frameworks, use web components, use the platform, bar. But JS is part of the platform. What's wrong with using JS framework? Foo, web components can be used anywhere, unlike component X or JS framework Y, which can't be used without that framework. That's not using the platform, bar. Sure, component X needs JS framework Y, but it all boils down to leveraging JS to render HTML and handle state events. So using the platform, then why would you not use a JS framework that does A, B, and C better? Foo, but you can't take the component X and use it elsewhere without a JS framework Y, can you? Your code is tied to that framework. How's that using the platform? Plus, web components are great support for A, B, and C. You can use Web Component Framework Z for that. So if
Yeah.
you need a Web Component framework to build your app, how's that different than using a JS framework? Also, JS framework Y can compile to web components too. So it's using the platform just as much.
I mean, this is how Twitter works. Like, this happens all, yeah, exactly. I mean, he has his finger on the pulse of that.
Yeah, I mean, this is why I posted that web component stuff, a week or two ago, because I was just like, this is just dumb, But this is the conversation, This is it. So he talks a bit about hydration and talking about reusing the word, and he pulled up some etymology and how people describe hydration. And
okay, yeah, he's a humanities student when he titles the section "Hydration" and its discontents, which, if you're not familiar, like, there's a Freud book called Civilization and its discontents. So
yeah, okay. I just wanted to throw this one out here. I'm sure you would appreciate this one, Dan. But yeah, I mean, it's tricky, right?
I mean, you made a very similar article with transitional apps.
Yeah. I was a little. I didn't get a mention in this one, so I was a little bit like, oh. But I mean, reading it, I could read. I was reading my like parts of my article in it. So
exactly.
But yeah, I just like the angle and I like the tone. That's the thing I love about this. I think it's a human aspect, and I think it's really important for people to kind of acknowledge that when dealing with these things and looking at these things. Yeah, I mean, and yeah, I mean, I've got a couple more. Yeah, we've already been going an hour, but we're almost.
Oh, cool. Whoops.
We're almost done here.
Oh yeah, I mean, I love the Astro and Solid conversation. I just want to it's no secret that I'm involved in the Astro community, and first of all, obviously this is my opinion that Astro and Solid are like the perfect duo. But the way this conversation went was like, it was just fascinating, and also X Element gets a shout out there, along the way, and I'm obviously friends with Leslie, who made it. So
what ended up happening, and where this comment I said I love Astro in the community, where we get to argue if syntax is more like Svelte or JSX and both be right, was that someone was their argument about it being the best thing. Warren,
I love Warren.
Svelte and Excellent would be even better, but Solid ain't bad. And I always laugh at this because it's almost anywhere you post something, someone's just like, but Svelte's better. Like, it's
the best part about this is Svelte could not be further from X Element. They are two very different things.
Right. But it was just amusing to me because it's very often. Of
course, Svelte has to be part of the conversation, right? Someone has to compare it to Svelte.
But it was kind of amusing to me because and often when people on the Solid side come in, they always come in actually blah blah blah, and they over explain, and they're probably the people that really annoy you. But on the Svelte side, they always are just like, it's better, and they don't say anything else. And so Dave was just like, okay, I'm taking the bait, right? And it started this thing Svelte and Astro share similar.
Which is funny because Astro literally is a variant of JSX.
Right, so exactly right. So it was really amusing to me. But I mean, I love it because this is the thing. If you use Svelte and you feel like Astro has become your templating language, that's success for Astro. That's amazing, right? Right. It is JSX. I actually, if you watch my stream on Astro, I was actually showing off some code examples, and this conversation goes on for a while, but. There's actually I have a code example in here from the stream, and you look at it and you're like, this. I think I'm looking at React, but it's an Astro file. But I still the fact that it can be at anything for everyone is really cool, and I think people undervalue that. I was talking to Matt from Astro, and he was like, well, we were thinking in the future expanding other syntaxes and let people make stuff more native to them. And I was like, sure. I mean, I get it. That's a direction. But you kind of already are doing a good job if this is what happens. If people are arguing Astro's best with Solid, no, it's best with Svelte, and they're arguing about it on a syntax level, that means you've succeeded. That's the thing people are really fickle and fiddly about.
When that's the argument, Astro has won because like either way you're using Astro. I mean, like, look, this is we're talking earlier about like explicit islands versus like optimized automatic islands, and this is sort of the benefit of the deliberate islands approach, is that you can make them as different from each other as you want. So,
but yeah, I mean, that's most of it. I had one other tweet that I grabbed that I forgot to talk about, but maybe it'll come up later. I'm not going to worry about it too much. It's just one other thing happened this week that I completely was not aware of. I pulled this tweet up before because I was talking about how different the perspectives were. And when I was looking at the Gen X, Gen 1 thing, I was thinking about this, right? This tweet again, because Michael Jackson, obviously, one of the creators of Remix, big on.
Are you really going to bring back a 6-year-old tweet here?
Yeah, I know. Big on server-side rendering, big on progressive enhancement, all this stuff. And this is like the exact opposite, just to show how much changes in 6 years, right? But some things never change. Look at who responded to him back in 2016, trying to explain why SSR was something worth pursuing. This made me.
Oh my gosh, this thing about the isomorphic router, and then like and it goes on to like make an isomorphic router.
Yeah, and stateless and progressive enhancement. Like, I mean, was Dylan telling them how to make Remix back in 2016?
Yeah,
I don't know. This one just. I didn't realize this. I focused on Sunil's thing about because SSR and other places in the world that have performance things, like it makes a difference. But Dylan was here. No one really noticed. I think I like these tweets. That's why they have now. Not that this was actually a particularly popular tweet either. Maybe I go back to the beginning. It's like, yeah, but like it just, I don't know. This is just, it's one of those things where like, it's funny. I now remember what it was when I was reading that article that was talking about hydration from that social side. They basically referred to Marco like this framework lost in time. Like
it's like Marco's been making the same arguments for 2,000 years. Like,
right, like that's what it sounded like. And when the timing with this was just perfect, because I was like, I guess it was, because if I look back 5-6 years ago, I'm gonna find, or 7 years ago maybe, I'm gonna find Dylan and Michael fighting the good fight, and people just completely ignoring it. Like, there's like history here. No one's going to do this kind of deep diving, but if you look back, you're gonna find the roots of what is like where we are today. It's crazy. Anyways, this is why building in public and stuff is important. Talking about this, you make kind of a history. These articles, you see the progression, you see the thing. I'm a bit of a historian this way. I look at the stuff, because when Solid was something I was aware of because I worked on Knockout, and I looked at these technologies and how they built up, right? And for me, Solid Knockout had something that was really good and kind of ahead of its time, and I built Solid on that. And it's funny because when React hooks were announced, I already had 8 years under my belt building with these compositional patterns. Like, it's incredible amount of experience. You get more experience when you have like thousands of people using your framework, but 8 years is still a lot of time to learn stuff, even for a few people. And when I looked at Marco, when I joined on that team, it was like the same thing. It's like everyone's talking about this now, and obviously I got in a little ahead of those conversations. But Marco had like 8 years and at eBay scale of learning and stuff. You don't think they've learned things that we're going to discover all over again with React 18 or with Astro or Quick?
I think there's so much about this. I mean, you never know when what you're invested in is one day going to become the topic of discussion and the sort of you know, opportunity point that people see. And also it's also like you should keep your eye on who knows what and wow, and like who you can learn from. Like
look at this. Explaining partial hydration to Michael Jackson. You can
who now is like, yeah,
without waiting for the JavaScript to download.
Yeah, like Remix is now the forums guy, right? Like we can use forums to do everything, and here's Dylan like teaching him that principle 6 years ago.
I mean, to be fair, he's old school, so he was aware of this. I think this tweet was just being a bit like, you know, off the cuff, you know. It's just funny to me because when you read it out of context like this, it looks like exactly what I'm saying.
Right. So, yeah. I mean, yeah. We can give MJ some credit.
Yeah. So it's just it's little things you find. Anyways, I think we're done here. This was This Week in JavaScript. I want to kind of change over. We've been talking too long, and we need. I think you're East Coast, right? So we're going to try our best to kind of dig into this as much as we can. So hopefully everyone's still with us. So yeah, I think it's time to close down these tweets.
Yeah, it definitely leads into what we want to cover, which is like breaking down the topics that people are talking about, whether that's rendering on the client or the server, routing, and of course the big bad hydration.
Yeah, so I think for me, where I want to start is looking at the overview of a page load is what I'm going to call it. You know what? I'm going to make a little banner for it so that I can actually throw it on the screen. Overview.
Yeah.
This is, and I got to give Theo a shout out. I don't think he's around tonight, but he was kind of showing people some of these things on stream, and I like the way he was talking about it. So I want to kind of go there on this because I'm going to use like the classic network diagram approach for a second. And I think this is going to help us because we need to identify, before we even talk about things, the terms that we're talking about, like what are all these like acronyms that everyone goes off about when talking about performance and page load and stuff. And for me, the easiest way to draw this is starting with 2 lines, you know, and one line is the user and the other line is the server. Okay. And we're gonna do like the arrow thing where we go back and forth and talk about the flow of just what happens when you load a web page. I think because we'll talk about portions of this, but this is going to be like our legend for a conversation tonight, because then we can actually.
Is the page in the middle, by the way? Because like the page takes the input from the user and fetches from the server.
You'll see what I'm talking about here, because what I'm going to do is I'm going to just go user server, and this might be an oversimplified model, and we might have to do some other stuff in a minute. But the reason I want to do this is because first thing that happens is we hit a URL.
The request.
Yeah. URL request. So this is like you go to a page, okay? And I'm going to talk about HTTP because I'm going to talk like basically about like our standard HTML page load, because you can request a lot of things from a server. You can request APIs, you can request, you know, a ton of things. But I want to talk more about like just the standard web request. And actually, is anything going on thing? Yeah. I might want this eventually. You're right.
Yeah, I'll be monitoring the chat. I have a separate.
Okay. So, I mean, the first thing you do is you hit that page. You know, we hit this URL, right? And then the server needs to, like, I haven't decided how I want to show this yet. Maybe I should just use some colors. The server decides that, hey, I'm going to, maybe an orange is a nice color. I'm going to spend some time here
deciding.
Yeah, pretty much. You're gonna be like,
yeah, what do I want to reply?
processing the request, right?
Yeah.
And the reason I'm giving this time is so that you can see like there is some work going on. And at a certain point later, and we'll dig into what goes on here, it's going to go like, okay, well, I'm going to actually respond back with something, and that something is going to be that HTML document essentially. So we're going to respond with the HTML document. It's actually going to be headers first, actually, to be technical, but like it's going to be headers plus HTML. Okay.
Yeah. One thing to like notice and that you might sort of take for granted about like the server processing the URL request. If you like, you might have this model of like, go to example.com/x versus example.com/y as being two separate programs running on a server. And that's not true, right? It's like example.com has one server, and when you hit X or Y, both of those go through the same program. Is that true?
Yeah, I mean, it depends, but yes, generally speaking, you have, I mean, there's more details there. I am going to focus mostly on the like like the JavaScript, not even JavaScript, but like we get into load balancers, and we can also get into like different models of concurrency on the server, multi-threading versus like Node.js's like non-blocking async. But generally speaking, you're hitting one web server. It might be a multi-web server, and it's gonna, it's gonna
route, right? That's where we get to the route. Like
it's going to know how to handle your request.
It's not like when I open a folder on my computer and I can choose one file or the other, right?
I mean, you're the router in that case.
Right. Exactly. Okay. Whatever. We're on the same page.
Okay. Where am I going? HTML headers, and I'm process. This is kind of like parse plus render HTML essentially. So this is when we actually is there an, kind of maybe I'll just do another line. What I actually want to do is move this whole thing. Yeah, there we go. Parse and render HTML. But the thing is, as part of this HTML, or perhaps the headers, we're going to find out that we need other assets. So what we do is we go back to the server again and go multiple times, actually, but we'll pretend like it's one here and go request assets. And by assets,
why we like send
JavaScript and CSS essentially?
Like what's the differentiator between what is considered HTML and what is considered an asset?
Well, I'm basically HTML is literally the HTML, and
I know I'm being sort of rhetorical here. Like I want to understand like why it was necessary to like not send the assets,
because we didn't know what we needed until we needed it, right? So because there's caches and stuff here, generally speaking, you're serving HTML, and as it hits it, when I say assets, I'm talking about images, CSS, JavaScript. I'm talking about all of these things.
So the headers plus HTML might say something like link rel equals this, and then only when that gets to the client is there actually an interest for the server to serve that file.
I mean, we're not talking about like HTTP push, and there's like other ways that the server, when it gets initial requests, can like pre-warm the stuff. I think some of the newer stuff in HTTP3 is interesting, but push had this problem because it wasn't great at cache invalidation scenario, because there is a cache here, so it would oversend. Only the browser knows what it doesn't have.
Okay, so there's this idea that if you go to the same web page again, you do not have to ask the server for that CSS file because you had it from last time.
Yes, exactly. Yeah,
that's the cache
or JS file. Yeah.
And when you say HTTP, let's make that explicit. The arrows, the way these two things are talking to each other is through HTTP?
Yes, yeah, that's the protocol here. And usually these assets are pretty cheap, to be fair. So we're going to have this arrow, like there is processing, but it's usually not. These are usually static. So sometimes the HTML is static as well, which shrinks that down. But essentially, now we respond with those assets, right? And the reason I want to show this whole thing is because I think it should be clear to you at this point that we didn't get any JavaScript to this point. Like maybe there's some inline in the page, but generally this is where things kind of start going, because now we're going to, again, put some time here. Parse, basically parse and execute assets. And we'll just give it a bunch of stuff. Okay. So let's go. Parse. So
yes, we got some caching headers on your CSS will determine that, and Dylan sort of mocks me a little bit, like you're missing an SSL handshake here.
You man, I'm not. I don't even want to go to the network layer really. I mean, I'm taking this mostly from the level.
I think it's safe to say that HTTP is important to conceptualize, and the network handshake might not be as important, but
right. But the reason I wanted to show this is that some point after this point, some point down here, depending on how long this execution takes, we're going to get to a line, and at that point, it's going to be like there's going to be like a load event. Now, you might be like, what about everything else? Because you might have heard some terms, and we're going to use maybe a different color here, and actually we'll make load event at a different color too, because I feel like it deserves. Oh, wrong one. I feel like it deserves to be part of this other color thing. Like delete, like Scala skills are number one. But what should we make these event colors? Maybe like
green. I don't know, green is okay. And this is the earliest possible JavaScript event.
Well, JavaScript's, it's a little ambiguous on where the JavaScript comes in with the load event, but generally speaking, once it's done kind of handling all the stuff that comes in for the page. You guys in the chat are the worst. See, this is the only reason why this stream might not be the best idea, because the people who usually watch this stream, a lot of them are really into
it's kind of, I was kind of expecting this, and it's okay. I'm hoping that we can use this as the fodder for creating more beginner oriented standalone videos, but yeah, I guess I hope that there's still stuff to learn if you already know all the stuff like the back of your hand, but maybe that's not true.
Okay, so what I'm putting in here is there are a couple things that are actually that we can actually say with certainty, and one of those is time to first byte, which is very often abbreviated to TTFB, and TTFB and load event are two things that are this can shift a little bit, but these are things that are kind of fixed. Different architectures, some of the other stuff happens, but we measure time to first byte, but first get that response back, and then there's a load event. Another word that you're going to hear often here is something called time to interactive, or TTI, and it is also kind of sometimes I'm looking at the load event. If it's like a client rendered architecture, it might actually It's basically synonymous with this load event because usually there's a break. Sometimes you fetch async data at this point, and well, I guess it's not fair.
You're saying there might be a possibility where the load event triggers, but we won't consider the page interactive yet?
Yes. Yeah. Because it hasn't rendered. So at Sunnis, I feel like I'm doing a terrible job here because some of these things are fixed and the other things actually changed dramatically based on the architecture when these events.
So the load event is more independent of the architecture because the idea there is just the browser's finished for now. Is that fair saying? Like the browser's finished, executed.
Yeah, the browser only knows to a certain point. Like when it finishes loading all the initial scripts and running them, it's like, okay, I'm done. Or like,
yeah.
Like when it's in that thing. But what ends up happening is like other stuff occurs, perhaps. Like you fetch from the API, but you still haven't rendered the page. Like if a client rendered page the whole page might be blank to this point. This is why I can't put in the other metrics. The other metrics that are important to be aware of, I'm going to put them over here, is first paint. I'm going to write them out. First paint, first contentful paint.
And these are super dependent of your architecture, you're saying. Like it's, if you build your app so that as soon as that parse plus render HTML happens, there's content on your page, like maybe it could be even back there? Or is the earliest what's the earliest that your first contentful paint could be?
The first contentful paint technically could be right.
Yeah, that's what I was curious about.
That's the earliest. But that could also be your largest contentful paint. All of these, maybe I just grab the whole block, could be
anywhere on the spectrum, pretty much.
Yeah, sorry. Why did it grab it? Yeah, sorry. They can. Yeah, it's in the wrong place. It's almost like I want to move the whole thing over to kind of explain what I wanted to do here. Maybe I will. Give me. There. This whole thing, these ones can basically span anywhere starting from here to like infinity down here. Like
it's much later. Okay.
Like
so these are sort of
interactive. I mean, time to interactive is going to be after this most of the time, but essentially what I'm trying to get at is like these things could span anywhere over this time period, depending.
And these are observational, sort of like the load of it is more procedural. Like the browser always goes through a process, and at a certain point it will say, hey, I've loaded. But this is more, maybe you have to understand a little bit about what the page is wants to be before you can say when the paints happen.
Dylan brings this up. There's the DOM content loaded and there's a load event. And maybe we should look at a real page. I don't have any images on the Hacker News page to see what I'm talking about, because when you go into Lighthouse and you do this little game here, you'll see these events that I was talking about. That's what these things are, right? See, there's DOM content loaded and there's loaded on load event. I'm usually, and again, this is, it's like there's some async stuff out here, like Grammarly. Like, let's not do this, and let's go incognito again. Oh, did I already close it? Okay, new incognito window. Let's do it again. Reason she want to show this off is because I guess. See, look at large contentful paint sitting out here. The load event and the DOM content loaded are they're always around this range. I actually look personally for the end of JavaScript running tasks.
So what's the difference between loaded and DOM content loaded.
Well, Dylan told us here.
Yeah, but it doesn't make sense to
after
me.
HTML and blocking assets are done, instead of load, all assets initially requested on the page are loaded. But see, yeah, I mean,
what is it? What is a blocking asset? Let's talk about that.
well, like inline script tags are a blocking asset.
So the idea is
HTML
that,
itself.
okay, the idea is that, like, you know, when that HTML is first rendered, the browser says, okay, great, I need to go grab all these assets. There might be further assets that are blocking. Oh, okay, great. This was confusing me. So you can like here it's like you load first, and then there's still blocking assets, and then you have DOM content loaded.
Yeah. So these events, I mean, when you look at them these enough, you're just kind of like, why did it choose this point? I don't know. This isn't a perfect science, but yeah, style sheets are blocking too. Yeah, that's another one. Like, there are a bunch of blocking.
So is the good way is the way of looking at it being like the browser is going to request a bunch of content, a bunch of assets. Some of those things are necessary or blocking, and some of those things are not. When the blocking ones are done, we trigger one event that's DOM content loaded, and when the rest, you know, all of the things were requested, then we trigger another. Is that fair?
Yeah, and I'm going to stop using this demo because this demo is bad because I'm using streaming. We haven't showed streaming. We should use a more typical. Yes, this is more typical. See, we loaded the HTML. This is the first part. Then from the HTML, we're like, oh, we have to request these assets. So we load the assets, and this is 2 JavaScript files and a CSS file, right?
Why is there, like, what asset is considered non-blocking here that is separating DOM content loaded from loaded?
Well, look, this one sometimes feels like it's just like, yeah. Let's look here. See, DOM content loaded decided that it lines up with this script execution here, or they decided, like, I guess this is when they had a breather, and this is when it's done. That's what sometimes I think loaded is the closest to like the hydration score you're going to get, where DOM content loaded. And let's see if I can bring this back. My scrolling, it's right there. DOM content loaded is lining up right here with let me see here. The initial execution of the HTML and the JavaScript that was on the initial page. Like,
okay, let me see this another way. There's never a request, a new request between DOM content loaded and loaded.
Well, I mean, it depends, but yeah, of the assets that we talked about to date, well, I don't think there should be, right? Like
the idea is that, like, browser requests a bunch of content. Some of that is blocking. When that's done, DCL. When all of the request is done, loaded.
Yeah, well, I mean, look at this timeline. HTML, there's some other tailing stuff. We fetch our stuff, and then look at this. This starts doing work when the CSS finishes.
What's this? What's doing the work?
Down here on the timeline.
Like what? The browser is using the CSS to, like, do a bunch of work. Yeah, okay.
Draw the layout, do the paint.
And we haven't done DCL yet.
Yes, and DCL is at the end of that. So you see this HTML, CSS.
Where's my label? Where's my DCL label? It's gone.
Yeah, we got to scroll. Yeah, it's part of this.
First,
confill paint, a large paint, because this all does it all at the same time. In DCL, it's all right here, essentially. Like, essentially, once it's done doing all the paint loading, the CSS, the paint, it's done. This is the critical path for DOM content loaded. That one always generally makes sense. This one sometimes feels, as I said, like YOLO. Like,
yeah, I'm curious, like, what tasks and loading, because it doesn't, like, if I look at the network thing up top, it doesn't look like there's any new network stuff happening between DCL and loaded.
Right, but loading isn't about I feel like it's it's they are expecting, it's basically after a bunch of like the synchronous scripts run that are.
Oh, okay. So this is actually really important. Load does not mean arrived; it means processed.
Well, the thing is, look, like, yeah. This is the network. At the end of the last JavaScript, we start running a bunch of this JavaScript code, and the load event looks like it sits in there at basically the first pause. This task is a micro task queue. Like it's essentially this is the end of the JavaScript. It runs that JavaScript, and then it pauses right here because you get to a new micro task, and that's when the load comes in. I don't know. That's my guess on, or that's like what it seems to be. So the load event, as I mentioned, like if you have a client rendered app, will happen at the end of the initial JavaScript running, but then you're like fetching some other
right. But one thing to just be clear about is whether loading is really about the network or really about the browser processing the stuff from the network. Because like it seems like it's not really about the network. Because first of all, DCL triggered before the network was finished, and load triggered quite a bit after all the stuff.
Yeah. DCL is about blocking and painting. Load seems to be, from my experience, tied to that initial JavaScript execution, like the non-async part of the JavaScript, like loading the assets, running the synchronous JavaScript load event.
One thing we're probably familiar with calling document.onloaded, registering an event handler to that. That's this red thing, right?
Yeah.
Okay.
Yeah. So, yeah. Hopefully this makes sense.
It makes a bit more sense now, but it also sounds like it's okay if you can't pinpoint and predict exactly when DCL is going to fire and when load is going to fire, because it's kind of up for grabs.
Well, it depends on a number of things. It depends on both the network time and the processing time and whatever. So, yeah, usually, like DCL is something, but no one talks about DCL and no one really talks about load either when they talk about stuff. The things they talk about are first paint, usually first contentful paint, largest contentful paint, time to interactive, which is,
if this was an SPA, would all three of those green labels be after the load?
Yeah, I mean, yeah. Let's look at it. Hacker News. CSR. I have an SPA for you, and we haven't talked about this yet, but this is an app that is completely client rendered. So let's go back here for a second before we go here. We've been talking about server rendered page. That page that I was showing you was this classic page. You saw everything happen. You saw the request for the HTML go out. This is the HTML coming in, right? So that long blue bar is basically waiting for this. Then there's some time, and then we see the yellows going out for the assets like the CSS and the JS, and that's the time you're seeing here. And then essentially, then we see the code at the bottom that was running, and then the load events, the DOM content load and the load depended on the CSS, which was blocking, was rated to DCL. The other one was rated to C. And this first contentful paint in our example was right where the HTML was finished rendering, right down here. That's where.
Can we define contentful?
Yeah, that's again fuzzier. I think it's based on a certain percentage of the page. Chrome just kind of defines these metrics.
So in other words, Chrome knows what the end state of the page is, and so they can be like, okay, a whole bunch of that was there here.
Yeah, I mean, I think they look at the viewport in terms of how much the HTML has loaded.
Okay.
Yeah.
But conceptually, the idea behind a contentful paint is like it's useful.
Yeah, because first contentful paint is about like the shell, and largest contentful paint is the thing. So they actually show you a bit where they continue. Largest contentful paint is like they decided when we got to the point where we'd rendered up to this point of the page, we've got the largest contentful paint.
And first contentful paint was just the container, or
and these are almost in our async example, they're almost at exactly the same time, because we served the whole HTML page in one go. Like the page is fully prepared when we sent it back, and for that reason, this is speed of painting. Like if we look down here, we're just like this is just rendering. Like this is 194, and this is I don't even know what's showing different on the timeline. It's actually the same time.
Right, we're getting super useful markup from the server, and the only difference between these green labels is how fast are we rendering that useful markup.
Right. Now, if we switch now to an app that is rendered in the client, like this app, you're going to see, maybe I'll go to the network tab and go to the preview. No, the response. You're going to see a bunch of HTML because it's fully server rendered. And that's what we're talking about. Now, single page apps that we're talking about is the complete opposite. When I go to this page and I go to the network tab and I refresh it, what we're going to see preview is nothing. We're going to see essentially this. This is all the HTML we sent. We literally sent an empty document with some.
Is this like way quicker to load than that other example? Because it's just
we're going to see that because we're going to do this right now. Okay.
All right.
So yeah, look what happened on our timeline. This is 73 milliseconds. This is all from Cloudflare Edge, so it's the same. This one's Netlify, but whatever.
Whatever.
Yeah. So my point is though, is that when we look at our network, not our network, our performance tab here, this was 165. So this took half the time to load the HTML.
Yeah. Okay. And now that second bit, those assets that are being requested by the browser are much more substantial in this version.
Nah, they're going to be the same. It's just the line looks larger. These are taking 30, 40 milliseconds. These are taking. Yeah,
but like, conceptually, wouldn't it make sense that now we're fetching the populated data in this version?
But that's the thing. Single page apps need to hydrate, which we haven't talked about. So you send all the same code. In fact, usually hydration is more code.
Okay, cool. This is good. We can get to this later. The cool thing to note is just like, let's look at those green labels here. Here we get a first paint like pretty early on because I guess as soon as I'm kind of curious why that first paint isn't way early. Like when we first get that very boring markup, like why don't we do first paint there?
Well, the thing is, there is some blocking things. It does take a little bit, but there is a difference here. First paint is at 126 here. You know what? Let's run it one more time. Let's see if we can get it any earlier. Damn it. The last time.
It's totally changed.
Okay, let's do zoom in.
This is so hard to learn from if every time you run this, the order of the labels changes.
No, part of it is just zooming in enough. This is actually the same thing. Look, first paint is at 130 or whatever.
Yeah.
And now, and at first paint standpoint, it's actually almost nothing on the page. I think they just call it first paint because like it rendered the HTML. First contentful paint is when it renders this shell that we're used to seeing here, like the header. Like you saw in the loading that it would be header and then it loaded in the content. And the difference here is the load event and the DOM content loaded event fired at this point, but we're not actually interactive. Yeah. Because essentially there's an API request. These new gray ones here, well, this was a fave icon, but this one here is an API request. So when we do client render, this all still happens, maybe a little faster because we aren't spending as much time here. But now at this point, when it's a client rendered architecture, we're actually going to go and hit an API endpoint. In this case, it's actually a different API. So as
it's going to be a different server, right? Yeah.
That's what I was saying. Yeah. Maybe we'll just put another line here.
It could be the same server.
It could be. But we're going to now request API.
And this is what we call Jamstack.
Yeah. Jamstack sometimes does a little well, I guess it's static, but it sometimes doesn't send a completely blank page. But my point is, we request API, and then we respond, and then essentially it's after the load event, and then we do some more work, and then it's interactive. So like there's a lot of handshaking going on here is kind of the point here. So like this in the end finishes up with its final paint and interaction and stuff at 250. But the funny thing is, this finished up with its final paint and everything at 230. The time wasn't actually that different on a fast network.
But we saw useful information way earlier.
Well, yes, exactly, right? Because this one didn't actually render the contents of this page until here, where this one did it.
I mean, that's sort of the difference here. Like, yes, like in total, maybe if you add up everything, they're about the same, but changing that order of the labels means that your user is seeing content earlier, you know?
So the gap between this first paint or this largest contentful paint and when it's done on a server render is what we call hydration, because it needs to do this JavaScript work to make the page interactive.
And time to interactive in this case is like a little bit even after the load event.
But the funny thing is, in this case, they're both interactive at basically the same time. But the difference is you can't interact with the page. So at this point, you're still seeing like the loading indicator until you get here, and then here you see the page. You think you can click on it, and you can't until here. So it's funny because yes, this is definitely better for visuals, but when this time gets long, bad things happen because it affects users' perspective. So I think this is why we focus so much on time to interactive, because it is actually important this whole time. First paint or large contentful paint is insufficient. We need first versus large so that we can differentiate. Like there's a huge difference between first contentful and large contentful when you're client-side rendering. But when you're server rendering, often they're the same thing.
Yeah, if they're close together, it means that the first thing your server is sending is useful.
Yeah,
it's significant.
Right, and the thing is, what we've been focusing on so far, I actually have in my article, and I made this table about when do you render. And I think this might I'm hoping we've talked a bit about these enough that maybe it's time to kind of put this in a chart so we can see it a bit. And essentially, I've kind of defined. I wrote this article as kind of a response to Adi Osmani's article, where he kind of shows all the ways to render. And the most recent one was very React focused, and I wanted to look at this in a very general sense. And what I've kind of identified was that there's basically a few different axes and tables we need to kind of understand for how I categorize things. And frameworks are actually a combination of these approaches. But generally speaking, on the render side, there's 4 choices if we just focus purely on the rendering at a high level. And we've talked a bit about static, but the examples that we're looking at right now are actually SSR and client. So when do we render? Well, when we made a request and after we fetch that data. And then in the client, we render in the browser. When is the data fetched?
Okay, gotcha. So by render, it means when do we generate HTML?
Yes, that's what I mean. Sorry. And then when is data fetched? Well, at the beginning of the request on the server. So this I said process the request, but this is also where
talk to the API.
Where I know you give it the orange side. This is where you do like data fetching.
Or this is interesting because not every site has to be giving you data. but like you can have a useful site that doesn't use a database or doesn't use an API. But like I this is an important differentiator in a realistic.
I'm gonna say data fetching or CSR is here, right? So this kind of doing, and what this means is time to first byte is relatively high for SSR.
Right, that's what we were talking about before. Like, wow, this is like a ginormous HTML file for SSR.
Yeah.
Cool.
Yeah, because what ends up happening is this shrinks considerably, which means this shrinks too.
Right, and it also means you get your first paint earlier, but your first paint isn't contentful.
Sorry, quick question. Is it possible to use a server framework like Express, Fastify, and return SR rendered SLH? Yeah, definitely. And Solid Start does support that. At the beginning of the stream, I was actually showing how we can use like edge networks to do the streaming. But yes, we can definitely.
Also, to answer your earlier question, it's okay to be drunk here.
I missed it. I was too focused on what I was doing. But what was it? Oh yeah, sorry. What I was getting at is yeah, we talked actually a bit about SSR here. But where I was getting at is that essentially when we look at this time to first byte, it's very easy to see how this kind of collapses up more when you have the client side rendering. We saw it visually too, but largest contentful paint, for SSR should be a little bit faster than client, right? I said they were comparable. On a slower network, you start seeing them separate, right? This was a 230 versus a 250. This gets more accented the slower.
And this is because the contentful paint depends on the data.
Exactly. So essentially, when we go to fast 3G, which never feels very fast, and we rerun our timeline to kind of like look, that was Surfer. You can actually see the loading state there.
Yeah.
Where do we get it? We get to 2000 for CSR. Like when you do it here on the SSR version, you're not going to see the loading state, but it's already done. It's done at 1400 milliseconds. So like client side rendering is like what is it? It's like another 30 or 60% slower or something.
Yeah.
So
and yeah, if your network is really slow and your client, I mean, what if your API is closer to your server than it is to your client? That could be another factor.
Right. Yeah. I mean, in our little diagram here, we made it closer to the client, but if realistically, it might be more over here.
Yeah.
Like we're just adding more time.
Yeah. But basically, like the more data driven your app is, the more content there is to fetch, maybe the more benefit you're going to get from SSR.
Right. Now, one thing that you saw here is with SSR, largest contentful paint and first contentful paint are identical, where it's much larger on our example, right? Because here, what is it?
Yeah, the first
14, they're all the same. DCL is okay. It's like 7 milliseconds. Let's not count.
The first paint is like kind of useless with CSR. It's like a white spinner or something, and then the first contentful paint is like a shell.
Yeah, so the first paint is client rendering is fast. 1248. First contentful paint here is only 50 milliseconds later from blank to this. It was pretty quick, but yeah, this is like a whole, like on the slow network, it's like almost a second later. So
someone in chat says we can do paint flashing. Can you turn that on?
Oh yeah, that's cool. Yeah, that's true. Yeah, I wonder if we'll see it. Sometimes stuff that's a little bit more dynamic. Let me see. Let's just rerun this like this.
Aha.
Yeah, you can see the.
All right, so that first green flash is the first contentful paint, right?
Yeah, and then on this one,
it's just gonna be 1.
Oh, I gotta turn it on here. Sorry. Rendering. flashing. Let's just do it. Yeah, you can see my hover state. Okay. It's going to be.
Yeah. Oh, interesting how the nav is later, the nav buttons.
Maybe I have some CSS or some. Yeah, maybe this one still has a transition in it. There's a small CSS transition.
I love this, but what I don't love is how the color isn't like the color should correspond to a label. So like you can see the first contentful paint as a different color than the contentful paint. Whatever. I'll talk to the Chrome dev team about.
Yeah, that's an interesting suggestion for them. But yeah, you can see the difference here. And then, as I mentioned, server rendering requires hydration, where for interactivity with the client doesn't. And just for a little bit more perspective, server rendering that we're talking about is like Rails and PHP and Next and Remix and SvelteKit and all like.
And this is interesting because, you know, Next and Remix, for example, do hydration extremely differently. So that will affect these metrics as well, right?
No, Next and Remix are like identical. Like
who's the one with the zero kilobyte JavaScript?
Next will have React server components, but that's a React feature, so Remix could have it too.
All right, I guess I was thinking that like one of these, like Remix. Basically, what I was thinking is that Remix has this idea that like you never have to hydrate for interactivity because your forms do all the work.
Right.
That's what I was thinking about.
We haven't talked about that, but that's the first column here. And I mean, yeah, I mean, hydration.
Like basically what I'm saying is for Next, like requires hydration for activity is always yes. And for Remix, it's no, sort of.
Yeah, I mean, if you want to talk about hydration, we can go there.
Right, we can get to that in a second. I think actually
the reason I'm not going there is because I don't think that in Remix and Next are like I don't consider progressive enhancement doesn't negate the need for hydration. Okay. If you have interactive JavaScript, like you can choose to not have interactive JavaScript, like you can always choose none, but like to effectively choose none, it's a very, very simple process. You remove the script tag from the page. Yeah. Like anyone can make a form out of HTML. You don't need a JavaScript framework to do that. So generally speaking, when I'm talking here, actually, I was wrong. It's not the first column. Remix and Next and SvelteKit, definitely this is where they live. Rails, PHP. This is the server rendering. You know, this is the client side. This is Create React app. This is you know.
Why is Marco not in there?
Because I have a small couple more distinctions here that we haven't talked about. Before I go to streaming, I'm going to talk about static for a second. This is the idea that at build time, you render it, or it could be from a cache. So technically with SSR, once you've rendered the page or ISG from Next and stuff, you essentially don't need to render it at request time, and you can do it like either.
Where is that cache? Is that cache in the client, in a CDN?
Yeah, CDN or wherever you're serving the pages from. So caching kind of blurs the line here. This is why when Addy did his thing, Brian was like, actually here, and he was drawing arrows and like doing this and sketching and scribbling over it, because he was like, well, caching completely changes the dynamic, and you can also cache in the browser. There's several layers of caching.
So someone in chat is very persistent. Every time we mention cache, they say make sure to set the cache headers.
Yes.
Can you explain what that's about?
Yeah. Because you can actually say how long this should like be good for, essentially.
Okay, gotcha.
So like this, it's very helpful to give these hints, you know, for the communication with the client and server. So like you don't need the reason the cache header comes out and Remix kind of was doing that is they're like, look, this is built into the browser. You don't need like ISG, which we haven't talked about, which is like incremental static generation or like fancy things. They're like, look, all that static generation is this side of things. All it is a cache. It's just when you're doing the caching, and so I do describe this as static here, but the truth of the matter is any of the SSR techniques here can leverage caching because they can just go, I'm not going to generate it again. You know, the way that ISG or incremental static generation works with Next is you make the request. They go, okay, well, we got the old version of the page, but we know that it's out of date. We'll just send you the old version of the page, and we'll next time someone requests it, the new version will be there because we generated it. Like it's just a stale while
another way of looking at this is the reason the cases when you can do SSG static rendering is when that usefulness of your data lasts a long time.
Right.
Because then you can go ahead and be like, yeah, I'll just build this once or every so often.
Right. And to be fair, some SSG frameworks do SSR now. I put 11D here. It's probably like they do SSR as well now. So it's like, it's kind of hard to split it.
I mean, even Astro used to just be in this column, and now Astro does SSR.
Exactly, right. And now it's very much, it does both. But you can see the advantages where you can do it here because look, developer or build time or whatever, obviously, data fetched, at that time. I say build time, but it could be at cache time or whatever. But look what happens. Time to first byte suddenly is low instead of high. Like it might not be as low as client, but it's low enough
because you're not fetching data.
You exactly. And lowest contentful paint, largest contentful paint, you can't get to it faster than this because on the client it's high because you need to fetch the data after the fact. It's on the SSR versions here, which we haven't talked about them. It's medium because you got to fetch the data, at the time the server gets the request. But here you already have it. So essentially, and first contentful equals first thing. So this is just like, you can't beat the performance here. It's just, so if you do both, which most things do, is you take a hit the first time, and then afterwards you go to this. But essentially, you can see why these are both very beneficial over client rendering, right?
If you have data,
because of this is the thing. So, that's too bad. Yeah, Ryan Florence does have good content. Remix really leverages certain parts of the platform where there's like other systems that might not be necessary. I do like the simplification and return to that a lot. Oh, I see. Interesting. Well, that's good. I mean, we were kind of pushing them a little bit. I guess it's like Guillermo's thing earlier where he's like, look, when you got the edge with a fast framework, like it's pretty freaking fast. Like you don't even.
So the idea is that you don't really need a cache if you can just run the whole thing again.
Well, and it's sort of like the edge is like dynamic is the new static. The edge is the new CDN.
Okay, so the edge lets you do the same kind of convenience and speed of storing a cache near the user, except now your cache can actually do the rendering.
Right. The only thing is, I don't know. I still feel like there's cache header consideration.
But you're like
the edge doesn't solve
the data problem. That's what I was thinking. Doesn't your edge still have to go fetch the data again?
And it might be farther.
Yeah.
So I don't know. I think there is cache headers. This is still a thing, but I wanted to. I left this one for last because this might be the most complicated of the bunch. But this is where React 18 Solid and Marco is. There is a solution which actually is almost like
for some reason, it's easier for me to understand the solid streaming thing than it is for me to understand what the heck React server components are.
It's not the same thing. That's the problem. There's two technologies, partial hydration and streaming. Marco does both. React server components does both, but they are two separate technologies. So this has nothing to do with React server components.
Oh, so React 18 is just because React 18 supports streaming, not because we have React server components.
Server components aren't even out yet.
Okay, this has nothing to do with server components. I can rest easy. Don't have to worry about whatever the heck that is. Okay. Cool. So
usually HTTP cache headers are more about telling the client to cache, although a CDN can pick up it on it also. And some experiences you probably don't want the client caching at all. Imagine a bid page, yes.
Oh, so sometimes the client does cache data, not just CSS files, but actual data.
You mean like locals? Yeah, yes. Yeah, I mean, you can fetch caches. I don't know if you've ever done that. Like, you can.
Huh, okay.
Yeah, like when you actually fetch, like APIs, you can do that. But the bid page is a good point, right? Because some people always go like, a lot of people talk about e-commerce, they talk about static and all this, and like eBay is all dynamic. Like, why? I mean, an auction site would need to be more dynamic than a typical.
It needs to be snappy when you're bidding.
Yeah, right.
Imagine
And
waiting for incremental static regeneration before you you make your bid.
right, and this is kind of why Marco is in this zone. Marco kind of was like, is there a solution that actually improves on this? And while nothing touches lowest contentful paint, you can't. If you look at streaming SSR, it's low, medium. This is a detail, but it's, other than being able to do it ahead of time, it has the best potential out of all these options for performance. And that's why React 18 added it. That's why Solid has it. And that's why Marco had it. And we've been watching this unfold, because on this page, when we refresh it on our slow network, you can see it take a second. You can see it like with the X do its thing. Refresh this one on slow network. It's faster, but then you're waiting for it. And
streaming is this middle ground.
Right, because what streaming does, and we'll show it in a minute, is, let's open our thing, and it's a slow network. Oh, it's funny. Sometimes it flickered there for a second. Sometimes you won't see it on stream. Yeah, see, it's funny because in this case, there's not enough data. Let's pick something that's larger. Like, do you have something with a lot of comments? 154 isn't a ton. Let's do it. Is it not going to do it for me? Just because I'm showing it. Sometimes streaming doesn't show up as nicely with network throttling in these tools. Yeah, see, I turned off the network throttling and you see it. Isn't that funny? Yeah. Essentially, it looks like client. Yeah. But as we saw on the performance,
this one important thing is the source of the data here is the server. The server is talking to the API.
Yeah, let me get the timeline here just so we can see it here. Because we looked at this one, which is basically like SSR. This is like your typical framework. And when you look at streaming, well, this one didn't actually give me a streaming looking timeline. This is sometimes the problem I have with these dev tools. Yeah, so it's not giving me the streaming looking timeline. Yeah, I'm not going to get on stream. I've shown it before. It's funny, when I turn off the throttling, we'll see it, but then I won't have as much of a defined difference. See, we see it here when I turn off the throttling.
What are we looking at?
It starts fetching the assets before the HTML is finished.
Yeah.
And the first paint happens here instead of here.
Right. So the idea here is you front load the data fetching by using some fancy HTML techniques.
Yeah. So I haven't showed you streaming.
Streaming.
Streaming is the data fetching happens here, but the difference is you take this end of this and you move it up like this.
Yeah.
And then the data. So yeah, I'm going to leave this here for the original, and we're going to.
Right. This is the trick. We don't wait. The server is still responsible for the data fetching, so it's not like the client rendered example where the client renders. So the server still both serves the HTML and fetches the data, but now it can start sending the HTML before the data ever arrives.
Yeah, and this kind of comes in maybe here, and in the end, it might be there around the same time, but this gap now has first paint. and first contentful paint probably.
And is it true that you can only do this if your rendering library is able to kind of pull apart the data from the rendering? I'm being sort of abstract here, but like Solid is it true that Solid is able to do this in a way that like another framework might not be able to?
Yeah, I mean, it takes some consideration because like React's had streaming since React 16, but no one calls that streaming in a modern sense, and they kind of deprecated that usage.
What was it really?
You could kind of render to a stream and then flush it as you felt like it. But the problem is, you like, when do you flush it? Because like, and flush, I mean send it over the wire, because React can only serialize so much of it. So like it was more like you could just be
that was really what I was trying to get at with my question.
Right, because how can you render something unless it's there? So essentially the problem was you if you're trying to output, like you have to make a VDOM and then essentially serialize it to HTML. So what you could do with the old streams was like, okay, I'm going to write my headers now, and then I'm going to, while I'm rendering the React app, and then I'm going to render out the React app, and then I'm done. This out of order streaming, or even in order with Marco's case, is that the render is actually set up so that it can actually send parts of the HTML ahead of time. And in our case, what we do, and I did this in the streaming stream in more detail, we actually send it almost like the client rendering. We actually show the placeholder, like we use suspense on the server, and just do the synchronous render with the placeholder, send that across the wire, and then as the data finishes, render the missing pieces and data and send those across the wire.
Yeah, you have to be able to serialize the data, understand where the data fit. It's kind of like separating the pieces of the puzzle in a way. You have to be able to know where the data is needed exactly so that you can send the shells, I guess. You have to decouple the data from the rendering.
Yeah, so it is interesting though, because on this page, even comparing to the client-side render, sorry, I'm going to put the paint flashing on again. You can see the difference. Oh, sorry, I'm using fast 3G. That's not fair. Oh, maybe not. Yeah, maybe not. Maybe it's not as big a difference as I was hoping to show. But what it does do is give, as you see on the faster network, it gave, when the HTML is able to get there fast enough, and there's a big enough gap between the HTML and the data loading, when this gap is big enough, you actually get almost like the client-side rendering experience, like this one, but like that much sooner.
Right.
So you get that loading state, and you can get things to the people as quickly as possible, and kind of leverage that. Whereas on the slow cases, like the worst case, what happens here is all the HTML kind of comes in at the same time. The network's kind of slow, so it just kind of comes in, and you don't see that flicker. And we saw this when we were doing the slowdown. It just looks the same as async, so it kind of scales well in both cases, which is what makes streaming interesting here.
We still need hydration to make it interactive, right?
Yes, still requires hydration. It's all the same thing, except this is an option now where we've just significantly improved our first paint and our time to first paint. I mean,
this is independent from the idea of the edge, right?
Yes, yeah. Edge is just changing like the lengths of these lines.
Yeah,
like, okay. You're just doing this. I thought it'd be really cool at one point to do like an interactive graph for this, but essentially, this is kind of the spectrum here on server rendering. So when I look at a solution, for me personally, this is what I'm asking. Is this primarily a static thing? Like caching is like a nicety that you're aware of that can work for any of these three. You can cache stream, like it's still HTML. Cache stream thing, like it might like move the last thing into place, but if it's in order, it doesn't. Like we cache streams at eBay, where it makes sense.
So if I'm using Solid, should I always choose streaming SSR over SSR?
The only trade-off is I mentioned here about the headers. The headers need to come in before any body content. And the challenge with streaming is you have to send those headers at this point before you've loaded the data. Which means you have to, at that point, you're going to have to be like, yeah, it's a successful request before you've actually.
You have to know a little bit ahead of time in order for that header. Okay,
well, the reality might be that there needs to be like this line might actually need to be more like this.
Because you need to do a little bit of data fetching before you send those. Okay, interesting.
Or, you check something, or the other option is say screw it and let the client handle it. Essentially,
meaning always send successful header.
Exactly.
Okay.
But it's synchronous. You do it's not exactly at the line. Like you do.
Ryan said we just described React server components, but I don't want to explain why we did because that's a whole rabbit hole.
Did we? I don't think this is not what I consider React server components. React server components do stream, but it's like another thing. I think yes, for where you're right, where we're sitting right now, we're just talking about 4 types of rendering. So when I look at my framework for server,
he was responding to someone else. I'm sorry. I didn't realize that. Okay, fine.
This is React server components. Yes.
State. Okay, that's the difference between that's the special thing about React server components is you have a stateful session on the server with your VDOM, which Solid, when Solid does runs reactivity on the server, you could argue that you're one step away from doing something like that.
Yeah, I mean, to be fair, I purposely don't. We removed for performance the reactivity on the server for the most part.
But you were playing in that game.
Yeah. But yeah, let's get there. Like the implementation of that is less important. I think the key part here is this is the anatomy of the fetch, and this is the first piece of what we're talking about here because this is when do you render.
Yeah, I love this, and we might not have a ton of time to build off of this, but this is a foundation. I like how you describe anatomy of the site fetching, and one thing I do want to maybe dip our toe in before I collapse is how this interacts with routing, how these 4 columns with routing.
I have another table about routing because there's 3 things that you should be asking yourself. You should be asking about rendering, you should be asking about routing, and you should be asking about hydration.
Wait, what happened with our headers here? Our server hybrid transitional client versus
because it's different. This is why these things don't belong on the same graph. You can't. This is not the 4 ways of doing it and the 4 ways of doing this. It's a matrix. You can combine these 4 ways of rendering with any of the maybe not all of them, but with any of the 4 ways. This is why this is a complicated thing.
Actually, this makes a lot of sense. Let's take the static example. In this static example, I could actually do client-side routing.
Yes.
So the 2 ways there would be server-side routing is my static example creates a different file for each route, and then I serve the corresponding one. Or my static thing basically generates one page with a bunch of JavaScript. The JavaScript has that routing solution.
Right, exactly, and it hydrates. So, for example, of that is. Jamstack is essentially when you have a static site and then you do client-side routing.
Yeah, wow.
So this is why
MPA, traditional MPAs could either be static with server-side routing or SSR with server-side routing.
Yeah, so what I'm getting at is that, exactly. What I'm getting at is, and we haven't added hydration. This is why when I see a chart the Adidas Monty chart, which has 6 things on it, I kind of laugh because I did the combinatorics. There's 128 possibilities.
Okay.
And this is with my generalization. There's more differences and subtleties here. This is why this is tricky. But that's why I had to break up the table. I'm can I do this with 3 tables instead of 1 table? and hopefully, like, I think this is why it becomes a bit of a game of like pin the tail on the donkey in the end, where you just go, okay, instead of focusing on this, once we understand what these are, maybe we should just pick a framework and then see what choices it makes across the matrix. And then
right, it's less useful to like imagine all the possibilities than to see concrete examples.
Yeah.
So I am curious though now, like I think I understand server-side navigation and client-side navigation.
Yeah, and maybe we like, yeah, I mean, a server-side navigation, just for, I mean, the beautiful thing about this Hacker News demo is I actually can show you the difference, because the server-side navigation is Marco, right? Look at the circle here. When I go to page 1, see that?
It fetches another file, yeah.
And you see the cool loading states? That's streaming at work. This is why streaming is so important in MPAs, because it looks like client loading state. You don't see any flicker, but you actually get instant responses. Streaming is so powerful in multi-page apps because you essentially, it looks almost like you have client rendering going on, right?
So if I had a piece of JavaScript fetching the next page from the server, it would look like this, but I would not get that browser loading state, right?
Yeah. And yeah, I mean, do I have an example of that? Because a lot of the solid examples use transitions, which hide that state, because like streaming is kind of showing it again. But if you have you're not going to see that, right? Like, actually, I do have one, don't I? Astro Solid example. Did I get that right? The Astro Solid example doesn't do streaming, right? So see this loading thing in the corner? But now we don't see the loading state. And we don't
this is pure static. What is this?
This is server
SSR,
with server routing, but but this one is without streaming, and this one was with streaming. So with streaming, we saw the loading state almost immediately, right? I mean, sometimes it's tricky to, yeah, you saw that, right? And without streaming, you see this. It looks like there's a bit more of a flicker here, but it's pretty good. There isn't flicker. The browser tries to hold the page as long as it can and then show the new page. So we don't have the flashes.
This gets to Thomas's question here. Can you explain why the orange top bar seems to stay consistent when you toggle pages? Is it because the top bar streams in as part of the first pane of the new page? I think it's because... Yes. Oh, okay, I see.
Yeah, because again, looking at our diagram here, with streaming, the browser actually, when you go to the next navigation, it holds till here and then does it. So
right. So it's almost like if you could slow it down super granularly, you would see a flicker. Like,
yeah, I mean, that's the whole thing. They try to hold it. I mean, that's what I'm saying in this Astro example. I am seeing a bit of a flicker in the text. I don't know exactly what's going on there, but essentially it holds it, and we're not seeing white paint flashes. People talk about MPAs and they're all like, oh, those white flashes of paint. That hasn't been the case for years. Like, it's the same way when people talk about hydration, they talk about that white flash of paint. That's garbage. That's not a real thing. Someone showed me something once that Cloudflare.com, like that is not... That is not... This is a single page app with like something weird. This is not the standard way hydration works, just like the white flicker paint. I don't know what's up with the site there. But someone pointed this out to me on Twitter, and I was just like, no, but okay, that wasn't a good example, but that's not what hydration looks like. So yeah, browsers are very clever about it. And what's cool about it, again, is with streaming, you get to show the next page that much sooner and give the people the more loading indicator. So in a sense, Marco's speed up here on streaming, maybe this is more jarring because I don't have a nice loading state. I don't have like the, you know, like the grayed out, like, you know what I'm talking about, like the nice placeholder things. But depending on how long it takes to load and whatnot, this can create a much more responsive experience, even though it's an MPA. But in both cases, like, it's pretty good, right? So this is server rendering. And so this is server and this is client. So you guys are probably like, what the hell are these two things in the middle?
Yeah.
But let's just look here. Server, there's multiple entry files.
Yeah.
Like there's, and when I say code entries, I don't mean HTML, I mean code. Like each page has unique JavaScript it runs, like each different page.
Its own bundle.
Yes, right from the top. Whereas in client routing, because they have to load the other bundles, there's a single root bundle that loads the other bundles, like maybe through code splitting. So it doesn't matter if you're on the comments page or the main page, you have one code entry. This is not about how many HTML files. As we mentioned, you can statically generate 20 HTML files and serve a single bundle, and it is a single page app. It is not a multi-page app. Right. Yes, because it's what we were seeing before with the streaming. The first pane includes the top bar, and the rest of the page is loading spinners. Yes, exactly. So you get this illusion of almost like you just get quicker responsiveness with streaming in the MPA, which has to do that full page on every navigation. But let's look here. With server navigation, you don't need any additional JavaScript in the browser to do it, right? I mean, we didn't look at this here, but I can tell you something about this network tab. There is no JavaScript on this page in terms of bundles. And guess what? Streaming added a little JavaScript, but it's actually inline. So guess what? Oh yeah, I got to redeploy this. This is actually annoying. This is Vite. This JavaScript bundle is actually nothing. Look at it. It actually has nothing to do with any code on the page.
It's like a dev server style.
Yeah, let me see if I got one. I got what? Marco, Hacker News. Let me see. Don't have it too. Okay. Yeah, this was a regression in Vite. We got rid of it. But essentially, there should be no JavaScript on this page. This file is just like a polyfill for something that like it literally does nothing.
And this is because Marco is completely effectively a static generation.
Well, it's the SSR is server rendered, so there's no need for it. I'm glad the Astro page we can see this, but essentially there's no JavaScript needed to do this navigation.
I guess what I was saying is, why does the Marco one not need hydration?
Because there's this example, this first page has no hydration. It's just links. Gotcha. Like there's nothing to hydrate. There's nothing you can do except navigate to new locations.
No interactive components.
So to be fair, on like Remix or literally any framework, you just remove the script tag and do this. But at that point, you still need to navigate out and do a new page. And once you go to a page that has JavaScript, like this one, you're taking the full brunt of it. Where a framework like Astro here we saw loads 5 kilobytes of JavaScript for this page, and Marco, which is a little bit larger right now, loads 18 kilobytes. To be fair, but this will be smaller in the next version. But my point is, like, it's not like 100 kilobytes. Like, what is it, like next? Actually, yes. Like like where are we?
So is this client?
See, this one needs hydration because we do this.
Yeah.
There we go. There's our 83 kilobytes. So
what's the routing here?
Yeah. So, anyways, next is a different case, right? We've been looking at server side rendering ones. Client side ones, single code entry point, doesn't reload in the browser, preserves client state, doesn't render on the server. It requires more JavaScript, An example of that's React Router, but this is FeltKit, this is Remix, this is Solid Start. They are all Next, pretty much all of them, and you can see that.
Even though we call the solid router isomorphic, you'll still say it's a client side. Like, what does it mean for
yes? Because it needs to. It actually, once you get here, look, when you do this, there's no spinner here. We're not reloading anything.
So
in fact, this HTML didn't move. It's somewhere in here that the content's changing. Let's see.
So the server does not help us do any routing here.
No, see there. It's just swapping out these HTML.
So what does it mean for it to be like a isomorphic nested routing solution, that kind of thing?
Which is what we have here. All it means is that it can render once on the server, and from any page it can render on the server. But when you swap into new sections, we can just swap out.
Oh, I see what you mean. So the server is aware of the routing solution so that it can serve you any of the pages as your starting point. But in order to do the mechanics of the routing, you need a client-side mechanism.
Yeah. Okay. Yeah. And you don't need one for these. Like, they don't need any JavaScript to move around here.
Yeah.
We need JavaScript because that page needs JavaScript, but we'll get to that in a minute.
Yeah, let's talk about these middle ones before I fall asleep.
Yeah. So Turbo Links is essentially a technology from the Rails guys, and it's built with MPA in mind. And I'm gonna pull out Turbo Links docs so that we can show what it says here. But it says, essentially, Turbo Links makes navigation of WebKit faster, get the performance benefits of a single page app without adding flexibility, blah, blah, blah. So what they do is when you follow a link click, Turbo Links automatically fetches the page from the server.
Oh, this is what I was telling you about. The JavaScript can fetch the new page from the server.
Swaps in the body, emerges the head, and they all occur without a full page load. I don't have a Turbo example offhand.
Why does it have to merge the head? Because like the CSS could be different?
Yes. Yeah. But Turbo is a lot of the kind of stuff that we've been looking at with some of the MPA frameworks recently. Maybe a more granular version. I don't have Ryan's example for me, which is right now at my fingertips, which was like a nested Turbo-like router where you could actually swap out the parts. He has a demo that I've been showed previously on stream, which I feel like actually be really useful.
So why is this better than the client routing?
Well, it's hard. Let's look at the table and let the table answer the question, because nothing we've talked about today yet explains why we'd want to do this. And the reason for that is, first of all, everything but server now is not going to reload in the thing. And it doesn't preserve client state. It's kind of the same as MPA. And it does render on the server after. JavaScript in the browser is the key part here. This requires a low amount of JavaScript. This is why I actually wish I had Ryan's demo, which I don't have at the moment, to kind of show you.
And this is because all your JavaScript is doing is asking the server for more info and then swapping things out.
Yeah. Ryan even did a nested routing version, and like where I was talking about where we're swapping it. And for you guys who do not know nested routing, I'm just gonna remix run. It's this idea that a page is a bunch of layers, so you can just swap out. Like if you click a nav here, it'll swap out this section. If you click a nav here, it'll swap out this section. And this kind of nested thing lets us kind of not re-render pages. And when I say swap out, I mean in the client side, it means just client rendering. But Ryan Turnquist made a version that does server rendering swap outs like this. And essentially, where I was getting at is it was 1.4 kilobytes. It didn't matter which page we went to. We navigated around. We swatched the page out. Like the routing was 1.4 kilobytes. And obviously the page, if they need hydration, would have different amounts of JavaScript, but it didn't need anything more. Whereas, I mean, client, I say high, but a client router also needs the JavaScript to render the page. So it's like The router itself
there's an overlap. You're saying you save some stuff.
The router itself might only be 4 kilobytes or 6 kilobytes or something, but you need all the JavaScript to then render the page. Where with a server being rendered on the server first, it literally could be, and we haven't talked about hydration, but the server is rendering the page, so you don't need necessarily need to have all the JavaScript.
What's the benefit of hybrid over server? I mean, I guess if you don't want to reload the page in the browser.
Ryan, if you want to send it to me on Discord, you can, and I'll get it. I don't have Discord open, but I'll grab it off screen and I'll grab it. So send me a private message on Discord. Yeah, and it could, which is, it doesn't right now, but that's, Brian literally whipped up this demo in an evening or so. There we go. Let me get this one going. And it takes a little bit because you actually have to define boundaries and you have to do a little bit of work here. Theoretically, they could though, which is what we're saying here. So let me show you this very, very, very simple example here. But this is a nested router using solid app router without hydration. But what you're going to see here is he made some special element to kind of denote stuff. Like, it does require different structure. When you swap, it actually does swap out the pieces. So this post details, if I go from post 1 to post 1 comments, it's only going to swap out this stuff. See, post 1. And if we look at the network and look at all, we're going to see the serialized kind of semi-streamable, like JSON format of sending the HTML of the wire and swapping the stuff out.
So arguably, this is more efficient than server-side routing because it only grabs the new stuff.
Yeah, but I mean, there's flaws here because how do I update it's not flaws, but it's like you still, this alone doesn't, like, what if I need to change the navigation?
Yeah, I don't really understand the benefit of this over server-side routing.
Well, it avoids like if you have ads on the page stuff, it avoids the full page. Like, this has benefits over server routing.
Oh, because you often don't want to reload the page.
Yes, yeah. Reloading the page is generally, like, there are benefits because then the browser handles the navigation and there's, like, it's more native and you can avoid memory leaks, and there's a whole bunch of things people will tell you, and it's in Taylor's article that I talked about that he shared this week. But generally speaking, we're really, like, the reason SPAs are so attractive is because of that. So these new approaches are trying to get us closer to single page apps from our MPAs. We haven't talked about why MPAs, which is the hydration, which we won't be able to get into tonight because it's too big of a topic. But essentially, we're trying to, there are benefits to having multi-page apps in terms of JavaScript payload, which I already showed. And this is a way of being able to bring those benefits to multi-page apps, essentially. Yeah, so what do we got here? Yeah, exactly, like animations, right? Like, I did show the loading state in Marco with streaming does a pretty good impression, but you wanted to be able to do animations, right? Yeah, smaller update. Yeah, just reading some of these comments here. Yeah. Suddenly you get a lot of the single page app trade-offs that you didn't have to deal with before. But as I said, this hybrid approach works with a Rails app. You know what I mean? Like, hydration is something specific kind of to our JavaScript frameworks in terms of how to add interactivity. But like, you can take classic static or SSR or streamed SSR pages and now not have to, like, reload the page. So that's the benefit of hybrid. It can be clunky. A lot of people I've talked to that's used hybrid approach say it feels clunky. And I agree. Every time I use hybrid, it feels clunky. The first time that it didn't feel clunky for me was actually using this demo. And I know there's not sending much data, but essentially the nesting routing, I feel like, is the savior. Being able, and HTMX, which I brought at the beginning of the stream, is also kind of in this idea where it can swap out pieces of the HTML from the server. And I think instead of treating it as a full page load like TurboLinks, is better along that path. So you might be asking, there's one more in this table that I drew here, and that's something called transitional. And I named this after the whole transitional app thing. This kind of routing, I've only seen one example to date, and that's React Server Components. We've talked about it on the MPA side about how we can achieve this, but it's a little bit different. I think it's funny. Client is like kind of an island. It's funny to use the term island over here. To get to transitional, you actually kind of have to attack it from the left. You can sort of see when you go back to the foundations, you have server, and then you're like, okay, let's bring it to the client. You got hybrid, and transitional is like taking hybrid to the next step.
How does this work?
And I don't have an example offhand because I'm not going to fire up the React Server Components demo, I think. I mean, I could, but essentially, we're back to having a single entry point. Like the single entry point might seem like a weird sticking point when you get in the middle, because the truth matters, you can always have multiple single page apps. Like you can have a server and each page is a single page app with its own navigation. So you can have, because an MPA can always have a single page app on it. So it's kind of funny, but this distinction is worthwhile because I'm saying a server app could have multiple transitional apps you want it, but essentially it's moving back to a single route for the application. So it's like client routing, but it does not reload in the browser. And this time it actually preserves client state, not just the stuff above where the transition happens, but like essentially it preserves it on a whole. And it, like the other one, renders after the fact. It requires more JavaScript, maybe not as much as client rendering, because it doesn't need to render all the components on the page, but it has the ability to, but it needs more to be able to handle this very complicated navigation. And
is this the streaming of routing?
It kind of is, like, in terms of, like, if you're looking for that hotspot, it's the thing that seems to have come, like, there's probably some terrible trade-off here, kind of like streaming has that headers catch, but it's the thing that's kind of wound itself into the middle where you get the best of this and the best of this, right?
Well, what you're saying is no one's really doing this right now.
Right. This is the thing that everyone talks about. You talk to Michiko from Quick, or you talk to the guys on Marco. We're all like, oh yeah, this is the thing. And when I wrote that article back in January, that server routing is the future, I was talking about this. What is it? Dev2. Let's see if I can find it, because I talk about the different types of routing here. When I said the return to server side routing, and I said, we have our classic multi-page app, which is the server routing. We have HTML frames, which is this turbo thing I was talking about. And then we have server components. And this article, kind of explains it a bit better. But you can already see this. When you click between invoices and subscriptions, yes, this swaps out, but this also has to change. And if you interact with something here, maybe something up here needs to change too. And as you navigate, you don't want to lose that state. So the way React Server Components does it is they treat the whole page like a VDOM, but they still fetch from the server. And there's a lot of talk about how we can optimize this, still use nesting and whatnot. But essentially, instead of just swapping out the HTML kind of naively, maybe, this transitional routing involves being able to selectively preserve the client and swap out, basically in React case, diff the server parts. Like, it's not just about maintaining the client islands, so to speak, which we haven't talked about it yet, but it's not just about You see how this is nested in here. It's not just about keeping the interactive parts of the page. It's actually that the stuff that is on the server, like the stuff that we kind of already, where is it here? Sorry, this one. Stuff that we know is static. Like I already said that this page doesn't need any JavaScript because it's all static. But if we go here, something that's more dynamic, there are static parts interleaved with dynamic parts. With this transitional routing, we would have the ability to take the things that are static on the server, essentially, the things that like aren't the client components here, and have them also update. Basically also have them still able to update, which without losing the without just replacing everything.
It's kind of like there's like you ask the server for the new states, just like Turbo does, but instead of just like swapping it, you do a diff.
Yes, exactly. And the reason that it's still kind of ambiguous a bit for people is like diffing is a very React way of doing it. Right. What if we could do it fine-grained?
Right.
Like there's different mechanisms, but you're essentially looking at a means to basically do the heavy lifting of the static parts on the server while you navigate, while being able to still do small updates, but keeping that server mentality. And the reason the server mentality is good, and I don't have an example in front of me, is have you ever been to a place where you've submitted a form, like maybe a login page, or you're submitting your new blog post? If you've ever done that, sorry, like I almost wanted to go to dev too, but yeah. I'm in an incognito right now. Sorry. Like if you've ever gone to that and let's say create a post and you click publish, if this is a client routed page, what ends up happening is you post your new thing and then you're still sitting on this page, maybe showing some indicator, and then the client goes, I'm going to wait to the response, and then I'm going to navigate you. Now that I know it's succeeded, I'm going to navigate you to the page that shows the actual post, perhaps, or maybe shows the list of posts or something.
Yeah.
And at that point, you go, okay, well, I'm going to that page now. Client fetch again. You actually do 2 requests. I don't know if this one.
Well, because you do a request to get to the new page, and then a request to populate the data on that page.
Exactly, right? But on a classic server rendered thing, you would just post the whole page would go there and it return with the new data.
Yeah, exactly.
And what's cool about this, like all the all of these methods that aren't client, they get to do that because you basically get to know you're on the server with the new location. The client doesn't have to go, oh, did this work? Did this happen? You literally come back with the new location, and the client goes, okay, this is a new location. I know what to do with it.
Yeah, as long as the server has a say in the routing, it can do some smart things where like intercepts a request and returns with a new route, I guess.
Yeah. I've separated these into those 4 categories because I do believe that this transitional routing is not the same as hybrid. Like it is a different step.
It sounds smarter to me.
Right. But it's probably
I guess the question is, if you want to keep it 4 versus 3, it would come down to, let's say they're both hybrid and transitional are very, well-developed options. Would you still sometimes choose hybrid over transitional? And if you would, then I would keep it as 4.
Yeah, and the truth of the matter is, there might be because the first of all, not every framework could support transitional in theory, and the other reason is, actually, I don't know. It's actually hard to say because there's perhaps hybrid is more efficient. Like we're going to see. This is the biggest question mark. I'm securing a space for this because I know it already exists and it will continue to exist. But as I said, when I say medium here, the truth of the matter is, like, I'm saying medium because in React, it means you have to bring in React plus more. I think the React server components demo was like 50 kilobytes of React before you did anything. And sure, 0 kilobyte components, but it's 50 kilobytes of React. And Turbo Links is probably like, or something like that, like Ryan's demo. I didn't open up the where is it? Was it in the other? No, it was here. Ryan's demo, when we go to the network and we refresh the page, we're going to see this 1.4 kilobytes of JavaScript. We're not hydrating here, but I'm saying that's it. Like we're doing all our routing here, and that, like, something like Turbo can be really, really, really small. So that there is a huge gap in our understanding today of what this means. But it is conceivably possible that this medium could be actually medium. Like instead of 50 kilobytes, maybe we can do it in 10. And this client side, as I mentioned, the client side router itself might only be 4, 6, 9, 10 kilobytes or whatever. But because you need all the code to render the page after the fact, it's not just high, it's like super high. Essentially, there's just no room. But we're only looking at one table. Once you had these two tables, suddenly the intersection of them starts making sense. For some of these things, high and medium are only going to make sense when we talk about hydration and talk about how much JavaScript code you need in the browser. Like essentially, these tables do impact each other when you have the combination, because you can have something that's high and then in another table have something that's like none or minimal, and you've basically canceled that out.
Right. It's like that's the example of mixing basically statically generating your one entry point route system.
Yeah.
And it's like, well, I could have done this with way less JavaScript if I chose the server side routing.
Yes.
By the way, I probably should sleep, but
yeah. This is where I wanted to get to today, especially as we spent an hour on This Week in JavaScript.
This was great, and I feel like this gives me a great basis for moving forward and like following the conversation as it develops.
Yeah.
So yeah, thanks so much. And I'm just looking at the chat to see if there's any stuff we really missed, but
yeah, a router in that can be inline, exactly. Like the Turbo example, you could literally inline the JavaScript for the router. Like it's barely any overhead. We always
Yeah, no, it's great. I kind of want to make a video out of just the part where we went through the fetch lifecycle. I think that would be really interesting.
Yeah, and I can give you the copy of that recording, or sort of like of the actual
Excalibur draw. Yeah,
if that helps.
Definitely save that Excalibur draw.
I next time I think it probably makes sense for me to pick up this conversation on my next stream anyways, because hydration presumably is still going to be the topic, and honestly, this gives me a little bit more time anyway, because it is a tricky topic. These ones are clearly tables, and you can just cross and mix them. But little sneak preview for hydration is it's actually 3 different axes itself. And I think this makes the conversation more challenging. So we'll kind of look at that next week and actually talk about like what the hell is resumability and what different types of hydration and how that plays together. Hopefully today, just from looking at this matrix, you can very clearly place most of the frameworks that you're familiar with, because 90% of them are going to be SSR or static
client-side routing
plus client-side routing. And maybe you use a few ones that are actually SSR plus like
server, Astro has server-side routing.
Like Astro, yeah.
Yeah.
Which is a little bit different. And if you're wondering what the Rails people are doing, they're using hybrid
plus turbo.
Yeah,
no, hybrid is turbo plus
plus SSR, right?
Yeah.
So, already from this, you can kind of see, so if I take streaming and I take transitional, now that's that React server components demo.
Yeah.
So we are actually, you can actually use this framework to at least talk about the solutions. I do actually think that while a few options do play to a couple zones, for the most part, you can actually fairly easily bucket the combinations. And it's not just 4x4, 16 combinations, to be fair. I think a few of them are vacant. But
yeah, it's kind of like what you were saying before. Like, we could talk theoretically about it, but it's more substantial to like look at examples.
Right. But I think with this is how I think about it. So I posed the question, I was like, I told them I think there's 3 things. I think it's routing, I think it's rendering, and I think it's hydration. The only problem is hydration is its own complex thing. So I think
so we'll get to it. Yeah, I think this is good ground setting so that next week you can be like, okay, we talked about all of this. Let's move in. And it'll be exciting. So thanks so much for bringing me on. And I definitely feel like I had a lot of my questions answered. So
I don't know if anyone in the chat, I feel like they might have been more helpful. But what I am hoping is that people come and check out this video will also learn something. I think this keeps on coming up in the Solid Discord. People posting links to articles and being like, "What's going on? Where is in the conversation? How do these architectural decisions actually impact things?" And hopefully those questions have been answered. So
I'll be splitting this up into or remaking videos as we as we move forward. Sweet. So
thank you everyone for joining us tonight. Thank you, Dan, for joining us tonight. This was a lot of fun, and I hope everyone has a great weekend.
Have a great weekend.
See ya.
Thanks so much. See ya.